For the lesson today, it would be on the Sec 1 Science revision. Yep, so welcome to Overmug. If you haven't came before, so welcome to Overmug. So for online attendees, make sure that you have downloaded the lesson material for today. So you can scan this QR code to get the 3 topic notes as well as the mock exam paper, which you are required to complete before attending the lesson today, because I'll be going through the answers later. Okay, so maybe just a little self-introduction in case you've never seen me before. So my name is Miss and I mainly teach IP sciences. That's why now I'm also teaching you all also. Yep, so I teach IP science and express also, but I specialize more in IP lah. Yep, so in case you're not sure what IP is actually the True Train program, like the 6-year program, yeah, where the syllabus is slightly a little bit more difficult than express, but it's still largely similar to express. Yep, so and for upper sec, I do teach chemistry and physics. So these are my teaching experience. So I've been teaching like at many places before. Yeah, so previously I was like teaching at the Learning Lab. I don't know whether you all heard of this tuition center. Yeah, so it's like I taught there for 7 years. And before that, I even teach in another tuition center called Wasteland. And I also did many relief teaching at the different MOE schools. Yeah, so far these are my track record. Yeah, because as mentioned, I specialize in IP. Yeah, so usually most of my students are from the IP stream. Okay, so just a little bit about myself. So I really love to play board games. Yeah, so usually in my house, right, I actually have a lot of board games. Yeah, so my love for board games had even entered the classroom where I even like introduced games to my students. So you can see like my students were like playing like with this thing called the wet heads. Yeah, so wet head is like something like I would ask my students, okay, you have to study certain concepts because it's important. Yeah, so after they study it, then the next lesson I will actually test them. Yeah, so if they answer wrongly, then they will have to pull the stick. Yeah, so if one of the stick would be the faulty one. And if that is the faulty one, then the water will start to leak. Yeah, so it's like very thrilling because you do not know which one will leak. Yeah, so it's like a punishment for those who didn't study. Yeah, then another game that I played is also like called Ions, where we learn how to make like chemical formula. So it's like a chemistry game. Yeah. So for me, I always believe in rewarding eager learners. Yeah, so for my lessons is that whenever my students score well for WA1 or WA2 or WA3 or even end of year, I will always reward my students. Yeah, so like for the most recent, this is my like Nanyang class. Yeah, so like the whole class, like 14 of them all got like A1 for WA3. Yeah, so then I decided to treat them like with Wingstop. Yeah, because they chose Wingstop. Yeah, then another class also like they did well, then I'll give them like plushy soft toys. Like you can see like they are putting up the soft toys. Yeah. Then I do a variety of treats. Sometimes it can be like koi bubble tea. Yeah, so they stack until like super high. Yeah, then sometimes I order pizza. Yeah, so I will usually treat my students who get like A1 or A2. Yep. So then sometimes we also order like acai. You all know that there's acai downstairs, right? Yeah. So if you're like overmarked students, right, we will have actually student discount for acai affair. Yep. So yeah, so these are the acai. Yeah. So for me, I find that like in order to do well in science, you need to have the interest in science, right? Yeah, so that is why you need to be interested in the subject. So usually I will try to include some hands-on activities. So this was actually a lesson on solutions and suspensions where we actually learned that you can actually physically separate the substances. Yep. So then they were actually like making like butter from milk. So so that means like for whipping cream, they actually separate butter and milk apart. Yeah, then over here it was like an experiment on like chromatography, yeah, and acid and bases for Sec 2. Yep. Okay, so done with the intro of myself. So just to let y'all know a little bit about Overmark in case you haven't heard of us. Yeah, so we are actually a very well established brand tuition center where we are actually located across whole of Singapore. So right now you're actually with me at the Bukit Timah branch. Yep, so we actually have over 1,000 students across 7 branches in Singapore. And you can actually easily find us on various social media platforms like Telegram, TikTok, YouTube. Yeah, and we actually also do like podcasts. If you listen to podcasts, yeah, it's posted on like YouTube. And so far, this is our track record is that we always produce very good results. Yeah, we are able to get students to achieve 70% distinction rate. Yeah, and our teachers here are all at least university graduates, so you are in safe hands. Yeah. and that I don't know whether you all seen us before on like featured on newspapers. Yeah, so we are also featured on like Straits Times, Today newspaper, various newspaper, got Chinese newspaper, Indian newspaper also have. Yeah, so Overmark is actually the first tuition center to host such like large scale mock exam event. Yep. So if you were to like become our student in future, yeah, then you will actually as an overmark student, these are actually the benefits where you will actually get like a set of like curated notes that is like specially designed to cater to teach you all with all the teaching tips, yeah, and answering techniques, yeah, as well as we will do like WA revision, mock exam for end of year, yeah, as well as like practical, yeah, you see that like we do a lot of practicals during lesson time. Yeah, then if you all need help, yeah, we will actually be able to give you like consultations after class also. Yeah, but some of my students don't really go for consultation. They usually like to text me. Yeah, so I'm quite reachable. Yeah, so usually my student will text me, then I'll just answer them on the phone. Oh, hello. Let me see. Maybe can you take a seat over there at the corner? Just to check, have you collected the revision kit yesterday? Have you completed the mock exam behind? And then you try your best to complete as much as you can because I'm going through later. Okay, so yep, so let's begin with our lesson now. So for the lesson today, because time is quite tight, I won't be able to go through every single chapter. Because if I go through every single chapter that you are tested in end of your exam, I can only maybe do 5 minutes per topic, which is not in-depth enough. Yeah. So instead of just like speeding through, I will actually go in depth for three topics. So these are the three topics that will be selected for today. Then after I'm done going through the notes, we will then go through the mock exam correction. That's why I said that like you have to finish the mock exam as soon as you can if you haven't. Because later I'm going through the correction. And later I will also be giving you the answer key in soft copy where you can actually go home and slowly write in the correction or just in case like later maybe you can't write fast enough. Yeah. Yep. So yeah, so that's all. So let's start off with the lesson now. So maybe I will just repeat again for the online attendees who are late. So for those of you online, if you haven't collected the lesson material for today, which is the revision kits, yeah, because we were distributing yesterday at the MRT station, can you scan this QR code right now to download the lesson material? Okay, so let's begin with the lesson now then. Hmm. Oh, oh, thank you, Wayne. I think it's okay. Because if there is two, then if the first one cannot work, then the second one will work. Yeah, so it's still okay. Okay, so yep, let's begin with the lesson now. So this is the handout that you all have, right? Yep. So for the three topics that we are doing today, I will just go in sequence according to the contents page here. I will start off with separation techniques first. So can you all flip to the page on separation techniques? Okay, so for separation techniques, take note that for this topic, right, you don't study one technique by one technique on its own. Yeah, what you need to do is you have to look at them as an overview because you should know that whenever you have questions like maybe from school or maybe in WA, you realize that usually teacher will mix like a few substances. Like I say that I mix salt, sand, and maybe like paper clips. And then I ask you how do you separate them? Yeah, so that's why whenever you study this chapter, you should study them as a whole. You cannot just study like individually. Yeah. So what you can do is you look at the states. So you check, are the substances you are separating, is it solid and solid, you are trying to separate them? Or is it like solid with liquid, you're trying to separate them? Or is it like liquid and liquid, you're trying to separate them? So if both are solid, one possible method could be magnetic separation. So take note that magnetic separation is usually one of the first step that you can do if magnetic separation is one of the possible method. Yep. So can you follow me and copy this down? Oh, hello. Yeah, come in. Sec one science, right? Okay, I think need to squeeze a little bit because not enough seats. Sorry, those online. Give me a moment. I come back again. You collect the lesson material from it. A lot of friends, is it? Maybe I get over share then lesson, is it? Hello, I'm back. Okay, so yep, so whenever you have like maybe like many steps that you want to do, maybe you want to do filtration, you want to do like magnetic separation,
Excuse
you want
me.
to do this and that. So usually what you do is you should choose magnetic separation as the first step.
Excuse me. Where are these notes?
You can either collect from the MRT station or you scan the QR code that I showed just now. Or like, were you late? Is it that you didn't scan the QR code?
Yeah, could you like scan the QR code again?
Ah, yeah, you do a quick scan now so that I can move on with lesson. Done?
Yeah.
Okay.
Thank you.
Okay, so for the yep, so for magnetic separation, take note that there are only four materials that can undergo magnetic separation, which I believe you all should know, right? Because it's like covered in primary school already. Okay, then next, what if the two things are not solid? So if maybe I have solid and liquid, then how? Okay, I would say that most of the solid usually is not magnetic, right? Because only four materials are magnetic. So if they are not magnetic, what you can do is you can check whether is one of the solid soluble or not. If one of the solid can dissolve, then you can actually do yeah, dissolving. So once you can dissolve one of it, it becomes liquid. And now you can then see which method to choose. So among solid liquid separation, there are many methods. There are like filtration, crystallization, evaporation, simple distillation. So among these four, which method to choose? So what you need to do is first you check your solid, is it soluble or not? Yeah, because if your solid is insoluble, that means cannot dissolve, you should do filtration, right? Because you can collect the insoluble solid in the residue above. But then if your solid is soluble, then there are three methods. But it's not anyhow choose, okay? How do you know which method to choose? It would be based on your experiment. Do you want to collect the solid or do you want to collect the liquid? If you want to collect the solid, then you should do crystallization or evaporation to dryness. Because during these two steps, you realize that the water will just keep on evaporate off and escape into the surrounding. As compared to simple distillation, this would be when you want the distillate. So ask you if I write over here that only when I want when I want liquid, I do simple distillation. But if I want solid, can I do simple distillation? Because after all, simple distillation, when I heat it, yeah, the liquid will travel out through the condenser and then I can collect the liquid. But what's left behind is the solid, right? So can I also collect the solid? That means if I want to collect liquid, sorry, say wrong. If I want solid, is it possible to also do simple distillation? Because there's solid left at the back. So do you think is it okay to do simple distillation if I want solid? What do you think? Can or shouldn't? So can I use simple distillation to collect solid? Or no, shouldn't use simple distillation to collect solid? What do you think? Before, right? So how? So everyone expressionless means what? Don't know the answer, is it? Okay, so I shall tell you now. The answer is no. If you want solid, you shouldn't do simple distillation. Why? Okay, so let's go to the page on simple distillation first, since I mentioned it. If you can you flip to this page, page 14? Because you need to know that when you do simple distillation, what comes out is the water vapor, correct? So your distillate that you collected over here would be like the water, and this distillate is actually pure. So the pure water will actually come out and be collected as the distillate. So you need to know that what's left behind, it would be actually your solid plus any possible impurities. Maybe if maybe this plus you never wash thoroughly, then what if there is like some dirt or maybe dust, yeah, any impurities that's left, it will all be left behind. So left behind, it would be the solid plus impurities. By the way, for my lesson, whenever I write down any notes or I do any highlighting, can you all follow and note it down too? Yeah, so whatever that I write, copy it down. Are you copying? Yeah, copy it down. So this is the reason why you shouldn't use simple distillation to collect solid, because the solid over here will be mixed with impurities, so it will be impure. Okay, so if you want the solid, the method to choose would be either crystallization or evaporation to dryness. That's why it's mentioned over here. Okay, then next is between these two methods, crystallization and evaporation to dryness, Which one do you choose? It's not anyhow choose again. There's a fixed rule to choose. It's based on whether will the substance decompose or not. So if the substance were to decompose, that means it is unstable to heat. Yeah, so we will call it as thermal unstable. If it will not decompose, that means it is thermally stable. So class, what's the most common example of a substance that will decompose? This one you should know, right? It's in your school notes. Yeah, sugar, correct. Yeah, because sugar, you know, right, when you heat it, it can become like caramel yellow. Then you heat it even more, it can even become black color. Yeah, so that's why I need to know that crystallization is usually for sugar. Then evaporation to dryness, it will be for salt. Yeah, because salt, usually no matter how you heat, it will still be the same state. Yeah, it won't melt, it won't change in color. Okay, so just to check, everyone done copying, right? Yeah, so make sure whatever that I write, you are supposed to copy everything in. Okay, so let me just show you a quick video of heating sugar versus salt. So over here, let me maybe play back a little bit. Okay, so here they actually place sugar on the left and they place salt on the right. Okay, okay, let me just mute it. Yeah, I will voice over it. Okay, so now they are going to get a torch to heat up. Yeah, so let's take a look at what happened when you heat sugar. So you will see that the sugar will start to become yellow, so that's caramel. Then if you were to heat it even more, it will actually become black eventually. Yeah, so try to screenshot this in your brain, okay? And remember that sugar will actually decompose. You see, once it changes in color means it decomposes. Yeah, so that's why you should use crystallization method. So can you see it's getting darker and darker and eventually it will become totally black. Okay, then let me fast forward it to salt. So for salt, now they will also heat up the salt. Yeah, so you see, no matter how they heat the salt still look exactly the same. It doesn't change state, it doesn't change in color. Yeah, so that's why salt is stable to heat. That's why you can use evaporation to dryness. Okay, so what exactly is crystallization and evaporation to dryness? Let me skip to the page. So for crystallization, it would be on page 15. Can you all flip to page 15 now? Okay, so for crystallization, what you do is you will heat the solution until you get a hot saturated solution. What does the word hot saturated solution means? Anyone knows what does the word saturated means? What does saturated means? Very good. Yep. So it means that no more solute can be dissolved anymore. So this would be similar, like, you know, if you drink before like Milo dinosaur, yeah, it's like there is a pile of like Milo powder that cannot dissolve in anymore. That's saturated solution. That means saturated solution is super, super concentrated. It's the super concentrated solution. Okay, so next would be that for crystallization. So once you heat until this like super saturated solution, when it's still liquid form, you stop. You don't heat all the way until dry. If you heat all the way until dry, that's called evaporation to dryness. So only when got the word dry, it then means that it becomes dry. So over here, not dry yet. So once you reach this super saturated solution, and how do you test whether it is saturated? Do you all know? So like we say that here, heat until saturated. But how do I know if my solution is saturated or not? How to test? Does anyone know? Even for those online, if you are not sure, sorry, if you know the answer, you can also contribute also. Hmm. So how? Not sure? Okay, so what you can do is you put this glass rod, like the stirring rod, into the solution. If you see that this rod has one dot, one dot, one dot, right, of solid, that means it is saturated solution. Because this proves that your solution actually has solid. But once you dig in and out, like maybe for example, if I dig in and out of plain water, obviously my this stirring rod won't have any dots, right? Like won't have like solid on it. And that means this is actually not saturated yet. So that's how you decide. Yeah. Okay, then next would be after you done with reaching this saturated solution, yeah, you cool it down to room temperature. Then you will be able to get the crystals. But why when you cool down, then the crystal will suddenly appear? Do you know why? This can be a possible exam question. So why you cool down and suddenly, the crystal magically appear? Anyone knows? So no one knows? Okay, then good that you are here today. Okay, the reason is because when you cool things down, solubility of whatever substance. So the blank over here is for you to fill in context of the question. Yeah, so if it's sugar, then you say that the solubility of sugar will decrease. What does this sentence mean? You know that, like, for example, if you want to dissolve sugar, you should use hot water, right? So hot water can dissolve sugar, but cold water cannot dissolve, correct? And so that's why if it's cold water, that means temperature decrease, sugar cannot dissolve. If sugar cannot dissolve, means it will remain as solid sugar, correct? So that's why you will form your solid crystals, because crystals are solid state. Okay, so that's the reason how crystals are formed. So over here, I would say that this is like an answering technique. So if question were to ask you, explain why when you cool things down, then sugar crystals will be formed, and then you just write this whole paragraph in. So I would recommend you to, if can, you try to memorize answering techniques. Because answering technique is like answering templates. If you just, copy and paste it into exam, right? You can memorize and then like write exactly the same, you'll get full marks. Because all the key points are present. But maybe if you are the kind that, nah, like memorizing is not really for me, then if you want to write in your own words, can. Just have to make sure that all keywords are present. That's why recommendation would be to memorize the answering technique because all the keywords are already present. Yep, so this one should go and remember it. Yep, so as mentioned, if they cannot dissolve, that's why no longer remain dissolved, and that is why they will form crystals, which is solid. Yep, highlight it. Okay, so moving on to the next part here. So sometimes question might ask you, so my notes over here, I'm just trying to predict as many possible questions that may come out in exam and worksheet as possible. So another possible question that they might ask you is, explain why sugar is not suitable to be obtained by evaporation to dryness. And then if they ask you this, then this would be your answer. It's because they will decompose. They are not stable to heat. Yeah, then this would be the answer. So this is also an answering technique. Okay, then just now I was over here, right? Yeah. So between crystallization versus evaporation to dryness, I'm done with crystallization. Next, we move on to evaporation to dryness. So for evaporation to dryness, you realize that the setup is similar. So I'm still on page 15. So the page number is on the right side. So for evaporation to dryness, as the name suggests, you heat until dry. Yep. So that's why you heat all the way until totally no more water, until all the water has evaporated. Yeah. So this would be more for like salt, because salt is okay to heat even when it's dry. Yep, so based on this flow chart, I've completed, okay, I didn't go through filtration yet because I went to the bottom row. Let me now go through on filtration. Okay, so for filtration, this would be the steps. So this is if the question asks you, can you list down the procedure, which can be tested, though less often tested. Yeah, I believe you all know how to carry out filtration, so I shall leave it to you to study on your own. So another kind of possible question is they might ask you, state how residue is collected in the filter paper. So the main reason is because of the pore size of the filter paper. Yeah, so filter paper actually has holes. That is why smaller particles like liquid can pass through, but the bigger particles like solid cannot pass through. So have you underlined or highlighted the word pore size? Highlighted? Okay, so moving on. Yep, so I think I've covered most of them. Okay, let's write in the examples, because sometimes question teacher say, I want to have like these three substances separated. So once you see the word itself, they need to know it's which method. So let's write it in. So for filtration, the common example would be to separate out sand from water. Things that are insoluble. Next, we move on solids that are soluble. So for solids that are soluble, like simple distillation, the common example will be, do you all know? So simple distillation is usually to separate nothing. Anyone knows? Simple distillation, what are we separating? Ah, correct, solid and liquid. But what's the common example of solid and liquid that we usually separate through simple distillation? Correct, salt from water. Yep, so it's salt, maybe salt from sea water. Sorry, let me amend it. Sorry, it's not separate salt, it's separate water out. Because remember, we mentioned that simple distillation is to collect liquid, not to collect the solid, because the solid is impure. Okay, so it's to collect water from salt water or sea water. Yes.
Using simple distillation causes the water to appear. Then how about crystallization and ionization? Won't there still be purity?
Okay, I'll cover on that point. Okay, so everyone done copying, right? The example. Okay, then moving on. Oh yeah, by the way, over here there are some other possible kind of questions that worksheet might ask. Like they might ask you, what's the function of each of them? So all these, I'll leave it to you to go and study on your own. All this you by right, you all should learn it in school already. And this is a very favorite question. So this one, please go and study this, okay? Yeah, they always like to ask you, how does water move in and out? Yeah, so you need to know that water always like move in and out which way? Okay, so you need to know that water always, oh, over here is wrong. Oops. Okay, can you write down? Water will flow in from below and water flow out from above. Can you help me to amend it? Why do water flow in from below and flow out from on top? So there are two reasons. One is, what if maybe what if your school, the lab, the tap, maybe very slow, very weak. Then if the water flow in so slow, if the water flow in wrong way, if the water flow in so slow, but then due to gravity, water flow out very fast, then what happen? Wouldn't your condenser not be filled? Yeah, so that's why we always go against gravity, so that the entire tube will be filled. So this is reason number one, that you want to fully fill it entirely with water. The second reason is because this is the exit. If any gas here not condensed yet, it will not be able to collect as distillate, but it will become like gas and then it will escape into the surrounding later after it exits. Yeah, so that is why we want to make sure that this is the last checkpoint already. I need to guarantee that like as best as close to 100% as possible to have as much of them condensed into liquid as possible. That's why at this part over here, best that it is cold, so that to maximize the cooling, so that it's as cold as possible, so as much vapor to condense as much as possible. Yep, so that's the answer. So this is a model answer also. So please study this, okay? You can try to memorize it so that you can write it in exam, then yeah, you can get full marks for this question. Okay, so moving on, next would be crystallization versus evaporation to dryness. Need to know the difference between the two. Besides to compare between substances that will and will not decompose, there are actually more to it. Yeah. So can you follow me and draw in this table? Yeah, so over here, this table will actually answer Maxim's question. Hmm. Okay, so one would be for crystallization. Then the other side, it would be for evaporation to dryness. So follow and join this table. By the way, for those of you online, if you don't have the lesson material, you let me know. Then I can do a quick flash of the QR code to let you scan and download the lesson material. Okay, so I shall start now. Okay, so let's go through the advantages first. Anyone knows we do the easier one first. We start with evaporation to dryness. What's one good thing about evaporation to dryness as compared to crystallization? Does anyone knows? Any of you knows what's the advantage of evaporation to dryness as compared to crystallization? I give you a hint, it's about the time. is faster, correct? So experiment usually like time is tight, right? Or maybe like if it's a upper sec is like if it's a practical exam, there's time restriction. Yeah, so if you can finish it faster, isn't it good? They can like answer more questions at the back. Yeah, so one advantage of evaporation to dryness is that it's very fast. Because you just on the Bunsen burner, you blast the heat all the way until dry, then the experiment end. Done. But crystallization is you heat until saturated. Then you put it on the table to let it cool down. So you need to take like hours for the crystals to form. So it's actually very slow. As compared to evaporation and dryness, I can complete like within half an hour kind. Yep, so the disadvantage is that for crystallization, it would be slower. But there's always no one best method. So if crystallization has its disadvantage, crystallization will also has its advantage, which is higher purity actually, as compared to evaporation to dryness. Yeah, so just now Maxim is like asking, right, like about the purity. So for crystallization, the technique will make it such that the crystals obtained will be purer than evaporation to dryness. Usually worksheet question, they won't ask you, why is crystallization more pure than like evaporation to dryness? They won't ask that. But if you can state, good enough already. Okay, so how to remember? Okay, so this is my way, my logic of remembering. It's not exactly like sciencey, yeah, but it's a way that is easy to remember. I'll go by this. You know, for crystallization, usually you have the saturated solution. Then usually what you do is that once your crystals are formed, you like pour away the liquid because you want to collect the solid crystals inside, correct? So imagine if example like someone achoo or maybe some dirt drop down, then there's some dirt in the solution, pouring it away, right? Aren't you pouring the dirt away? So that's why you are in a way pouring the impurity away. So that's my way of remembering. Like, okay, crystallization, I can pour away the impurity. That's why more pure than evaporation dryness. So if evaporation dryness, I have some dust inside, the dust will stay in my crystals. Yeah, because I'm not like pouring it away. Yep, so that's the way to remember. Okay, so everyone done copying, right? Because I paused here for quite long. Okay, so I shall move on. Okay, then next would be liquid-liquid separation. So if you have two liquid, how do you know which method to separate? So it is based on whether the liquid can mix or not. So if your liquid can mix, do you all know what is the correct term called? Start with letter M. If the liquids can mix, do you know what's the correct science keyword? Correct, very good. Miscible. Versus liquid that cannot mix, what is it called? Very good, immiscible. So which method to choose based on whether miscible or immiscible? So how you can remember is miscible come from the letter Mi, right? Isn't Mi like the word mix? That means mixable. But immiscible means you have the letter Im in front. What's Im? Im isn't it like impossible to mix? Yep, so that's why immiscible means impossible to mix like oil and water. Okay, so for liquid that are mixable, what's the method that you should choose? You should be choosing fractional distillation. Yeah, so fractional distillation usually separate two liquid that can mix together very well. So an example would be like alcohol and water. So one type of alcohol is called ethanol. So how to tell if it's alcohol, right? Usually the spelling, the behind is the same alphabet. The ethanol, alcohol. It ends with OL. You all know that alcohol can mix with water, right? So for example, right, you know the adults, sometimes they drink like alcoholic drink, and then if they put ice, then once the ice melt, isn't it water? And water can mix with the alcohol, right? So that's why ethanol can mix with water. So if they can mix, you use fractional distillation. If cannot mix, you will use another method called separating funnel. Separating funnel depends. Some school cover, some school don't cover in lower sec. Okay, so next part over here, the method. So if they ask you, how do you carry out fractional distillation? Then you just copy this entire paragraph off. Then you fill in the blank according to the context of the question. Because depend what substance the question is asking you, you then fill in accordingly. Then likewise, whenever they ask you for apparatus function, remember to be able to write it out. That means you need to play your part in studying it. Everyone done copying, right? Okay, so I shall move on. Okay, then next is take note that if you realize that, how come the distillate you collect is not pure? Distillate is the liquid you collect over here. Let's label it. So whenever is distillation, you will collect distillate. Then if it's filtration, then what's the name of the liquid that you collect through filtration? It's called filtrate. So need to know a different name, okay? Distillation, collect distillate. Filtration, collect filtrate. So if the distillate, you realize, how come like not quite pure? Then they'll ask you, suggest how you can improve the experiment. The answer would be, you use a longer fractionating column. Because fractionating column, inside there are glass beads. So the fractionating column is kind of like like for example, like Changi Airport, if you were to have like a very long custom checkpoint, like well, a lot of checkpoints, isn't it more likely that you can catch like any like maybe drug smugglers? Yeah, so if you have a longer fractionating column, that means you have more checkpoint to be able to capture and catch those liquid that haven't reached the boiling point to drop back into your round bottom flask. Yeah, so to ensure that only liquid that really reach the boiling point then can pass through the fractionating column and pass through the condenser and be collected as the distillate. Yep. Then next is if the boiling points are too close, usually the guideline is if it is less than 10 degrees Celsius, it would be not possible to separate them well. Next, if question were to ask you, suggest a property of the substances that allow them to be collected by fractional distillation. So again, I'm trying to like predict question for you again. So this would be the model answer. So you need to know that substances are always collected in increasing order of the boiling point. That means the lowest boiling point would be collected first. Then the highest boiling point would be collected last. Yeah, because you know your Bunsen burner, when you heat, is always from low temperature to high temperature. That's why you collect the lower boiling point first, then the highest boiling point last. Okay, so yeah, here's the QR code. You quickly scan it, then I shall move on. Wait, I think my words are blocking. Can, right? I changed the screen. Should be done by now. Okay, so back to the notes. Okay, so this is done. Oh, right. Sorry. Let me go backtrack. Just now I realized for the examples, I wrote in for fractional distillation, but I didn't write in for crystallization and evaporation dryness. Let's write it in. So crystallization, as mentioned just now, right? What is it for? Is to separate which substance? Crystallization. It is used for separating. People, I'm asking you a question, so I expect a reply. So crystallization is to separate out which solid? Sugar or salt? Sugar, correct. Yep, sugar from sugar solution. Wait, how come my words didn't appear? Okay, let me type again. Sugar from sugar solution. Then remember, I told you if you want the water from sugar solution, if you want water, you do simple distillation instead. Okay, then let's write it down over here for evaporation to dryness also. So for evaporation to dryness, it wouldn't be sugar, it would be salt from salt solution or maybe seawater. So similar to like what Jaden has mentioned, true that for evaporation to dryness is only limited substances. Yeah, because like those that can withstand heat, then yeah, they can undergo evaporation to dryness. So if you're not sure whether can they withstand heat or not, you just use crystallization. That means just to ask you, is it possible to separate salt from salt solution using crystallization method? The answer is yes. So crystallization can do for everybody, but evaporation to dryness only for substances that won't dissolve. Sorry, that won't decompose. Yep. So for crystallization, can you also add this example in? Hello, can you add it in also for crystallization? So in other words, crystallization can be for any solid. So I add in one more row again. So just now you had a row for sugar, right? Then add in salt. Then you can say that it is actually for any examples. Because whether you will or will not decompose, you can always use crystallization. But as mentioned, for salt, we will always choose evaporation to dryness because crystallization very slow. Experiment, we want to do it fast. Yeah, so that's why usually in school you realize your teacher teach you salt to be collected through evaporation to dryness so that it is faster. Okay, so moving on to the next section on chromatography. So for chromatography, also need to know the different parts. So do you all know what is this rectangle piece over here called? Besides filter paper. Do you know there's another name for it?
Miss,
Yes.
how about for like salt, right? I thought the solubility doesn't change a lot. Like
For
with
salt, the
temperature,
what thing doesn't change a lot?
the solubility in water.
The solubility doesn't change a lot. Sorry, I don't quite understand what do you mean by this
As
sentence.
in, like even when the temperature decreases by about like 50 degrees Celsius, the solubility only decreases by a little bit.
Then
So how are you going to collect like the crystallized salt?
how to collect the crystallized salt? Because when you heat it, usually it's like, like boiling time. And then usually when salt is inside water, salt is an impurity. Impurity will actually raise the boiling point. That means instead of boiling at 100 degrees Celsius, it will boil at like above 100 degrees Celsius. So from a temperature of above 100 over degrees Celsius, you cool down to room temperature based on Singapore, it's like 30 plus degrees Celsius. This change of like maybe 80 degrees Celsius is significant enough to be able to decrease the solubility of the salt to make it to form back to solid crystals. Yeah, so can still form back.
Yeah, but will it be like negligible?
No, because salt you will still be able to form. It's not negligible. It's a significant difference in temperature.
Okay.
So can still form, can still form. Thank you for those online. Yep. So for this paper, you can actually call it as filter paper, or you can call it as chromatography paper. But I think some of y'all heard of the word chromatogram also. So what's the difference? So for filter paper and chromatography paper, I would say this is the name for at the start of the experiment. So I have a blank piece of filter paper. Usually, filter paper you used before, right? It's round. If you cut to rectangle shape, it becomes chromatography paper. So it's actually the same piece of paper. Then once you conduct the experiment, once you have spots, I will then call it as chromatogram. That means chromatogram got results. So that means it will be more of the final state of the chromatography paper. So at the start, it's called chromatography paper. At the end, it's called chromatogram. Okay, next part over here on retention factor. This one depends. Some school may teach, some school may not teach. Yeah, so what retention factor is, RF value here, refers to how soluble the substance is. That means the bigger the RF value, the more soluble the substance is. That means they can dissolve very well. Because if they can dissolve very well, means that they will travel up very fast. So if you travel up very fast, and if you look at the formula, distance traveled by the substance. So this would be the distance traveled by the substance. You always base on the start line. Yep, so from the start to the center of the dot, this would be, maybe I color code it. So distance traveled by the substance, I shall highlight my arrow in green. So RF value is the distance traveled by the substance divided by distance traveled by the solvent. That means how far your liquid travel until. Yep, and take note that the value over here, it will always be less than 1. So if your number is more than 1, right, can you go and double check your answer? Might be somewhere went wrong. So this is one of the things that you can check during exam. And take note that if your answer is less than 1, that means the answer should be 0 point something. Then you need to make sure that you express your answer in, you don't know how to write, like how many DP or SF should you write your final answer for RF value? It's not the usual 3SF anymore. Usually science is 3SF, but for RF value, a bit special case. It's in 2 decimal place instead. So it's 0 point something something. Okay, so 0 0.2 more digits behind. Yep, so if your substance is super soluble, then it travel very high up. That's why the distance traveled by the substance will be very big. Oh. But take note that no matter how big it is, it will still be a smaller number than the distance traveled by the solvent. Yep, and in math, right, whenever you take small number, divide by big number, it will definitely be always less than 1. So this is the thing to check. If your number on top is bigger than wrong already, so check. Make sure that your numerator is always smaller. Denominator is bigger.
I have a question.
Sorry, Kaylee, can you repeat?
I have a question. You know,
Yes.
for the chromatography, right? Because
Uh-huh.
in my WA paper, I wrote like CM at the end. So, and then she minus 1 mark. Like, I wrote the units.
So for RF value, don't have unit.
Okay.
Yeah, the reason why don't have the cm, the reason is because you see, over here, distance, isn't distance in cm? Then you divide by another distance is in cm. Like, you know, math, if it's cm over cm, wouldn't the cm get cancelled off? That's why for the RF value, it would be no unit.
Okay,
Yeah,
thank
so
you.
that's why cm get marked down. Yeah, that's the reason. So can everyone note it down also? Yeah, because I don't know whether you can hear Katie who is sharing online. Yeah, so she said that like for her WA, when she include the unit for RF value, she got marked down. Yeah, because take note that RF value should not have any units. Okay? So let's move on. Done copying, right? Next part. So if they were to ask you, how do you conduct chromatography experiment? This is the model answer. And over here, again, same thing. So usually for my notes, I always design it such that I try to spot as many possible questions that might come out in exam or worksheet. Yeah, so if you see any similar question like they ask you, why start line cannot be submerged in the solvent? You copy this in, then you can get full marks already. Or maybe they ask you, state an advantage of chromatography, and then you write this in, then you can get full marks again. Yeah, so please go and like study it, okay? Because I'm trying to spot the possible question that might come out for exam. Anyways, all this I think you all should know. So I think I don't want to go through anymore because by right, all this your teacher should have covered, right? Anyone need me to go through any of the 4 section over here? Any points that you're not sure? Can understand all right? Then I move on. Okay, so then lastly, it will be reverse osmosis. This is more for like only G3 and IP students. You also need to know that reverse osmosis, reverse meaning you go in the opposite direction. That means you move from a region of lower water potential to higher water potential. That means you move from a place with less water to more water. Because mainly I want to collect as much pure water as possible. So in order to go in the opposite direction against the crowd, of course, you need something to help you out, right? Because you're going against the current. Yep, so you will need high pressure because high pressure, it would be to push the water molecules to the other side. And you will also need partially permeable membrane. Yeah, so for partially permeable membrane, it will be able to sieve out such that only small water molecules can pass through, but the big solid particles cannot pass through. So that's actually how we collect the, right down here, that's how we collect pure water from sea water. Also called, that's how we obtain our new water. You know, Singapore has this thing called new water. So that's how it's being done. So that's reverse osmosis.
What's the
Yes.
difference between
Vacuum distillation.
Again, difference between,
Vacuum distillation.
sorry, I didn't catch your first one.
Vacuum distillation.
Vacuum distillation. Most schools don't cover on vacuum distillation though. Yeah. Sorry, someone online was like speaking, right?
what's the difference between reverse osmosis and osmosis?
Oh, reverse osmosis is where you have the water moving from low water potential to high water potential. That means you go in the opposite direction, from less water region to more water region. Then compared to normal osmosis, you move from more water region to less water region. That means you move from high to low water potential. So if you move from high to low, it's a natural process. Because something like playgrounds, like if I want to slide from high to low position of the playground, it's very natural, ma. But if I need to slide from on the playground, I want you to slide up. Isn't it? Wow, you need to use more energy. So in this case, instead of energy, they are using pressure instead. Okay? Yes, Jaden, you have a question?
So right, doesn't like what if they're like molecules that are like smaller than the water, like then won't they also go through the membrane?
Um, if they have water particles that are smaller than water through, they will also pass through. That's why usually after you do reverse osmosis, it's not immediately drinkable. Yeah, so you also need to like do like chlorination to like kill all the bacterial germs and all. Yeah, so yeah, there are particles that can also pass through that are smaller than water. Yes, possible. Okay, so yeah, I'm done ready for reverse osmosis. Okay, so then next would be, I think that's already right for this chapter. Yeah. Okay. So let's now take a look at some questions that is related to separation techniques. So it would be, let me see. Let's take a look at question number 8 of the mock exam paper behind. Okay, so for question number 8 over here, so they are asking you which technique involve a change in state for these three here. So what do you all think is the answer? What's the answer for this question? I think some of you all have done it.
Evaporation
So
and
you
distillation.
choose
Evaporation to dryness and distillation.
oh, evaporation, dryness, and distillation. Yes, correct. Very good. So the answer will be A. And because for filtration, there's no change in state, right? The solid still remain insoluble, still remain solid. Then the filtrate, which is the liquid, still remain as liquid. Yep, so that's why the answer will be A. Very good. Okay, then next would be, let's take a look at question number 10. Okay, we can look at question number 9 first, since it's on chromatography. So for this question, they said that a swimmer is suspected to have consumed a banned drug to improve his performance. And this is urine sample. So they compare it with like the pure drug, which is the drug sample, versus his urine sample in two different solvents. So this one, they soak it in alcohol. This one, they soak it in water. And the statement over here, which one mentioned about the result is true? So which option do you all choose? Which one do you all choose? Yeah, correct. The answer is A. Very good. So as long as you see that they have spots that match, yeah, so you see this is like same height, right? Yep, that means yep, it do contain the drug sample. Over here also, you see, it do contain the drug sample. So yeah, both tests shows that there is the banned drugs. Did anyone choose any other options? You want me to explain for you for the other options? Sonia? Okay, then we move on to the next question. Question number 10. Which position is exactly 100 degrees Celsius? So the answer is, what's the answer? What do you choose? B, correct. Very good. Yep, so the answer is B. Because you need to know, salt solution. Salt is an impurity, right? And just now, I also did mention just now. Do you all know what does impurity do to the boiling point? What does impurity do to the boiling point? Yeah, correct. You make it higher because so how you can remember is boiling point is hot, right? So hot will become hotter. So boiling point will become higher. Cold will become colder. Because like freezing point, it will become like negative for water. Okay, so hot become hotter, cold become colder. Yep, so the boiling point will actually be higher. And plus, it will also boil over a range of temperature. That means the boiling point of salt water won't be fixed at like 110. It can be like 110 to 120 like that. So it will be over a range of temperature. Are you all copying? Can you follow and copy it down? Okay, then next let's go through another separation technique question, which is the open-ended question number 3. Sorry, question 23. Let's stick to question 23. An officer from the organizing committee of the Olympic Games suspects that these 3 people use the illegal drugs to help them to boost their performance. So they do vapor chromatography on their urine test, and the drugs that they want to check whether did they take in such drugs or not. So for part 1, they're asking you state which athlete took the drug. So what do you all think is the answer? So which athlete do you all choose?
Amy and Ash.
Yes, very good. It's Amy and Ash. Maybe for open-ended, I will just flash the answer instead. Yep, so the answer is Amy and Ash. Why? Because again, same thing, you just make sure you must match. So Amy, do you realize it has this drug T over here? Then next is that it also has drug P. So yeah, Amy definitely took the drug. Next, if you look at Ash, Ash has this. So Ash took drug R. And okay, that's all. Yeah, so Ash took drug R. So that means in this way, you will be able to answer the next part. Hey, wait, did I miss out something? P or T? P. Oh yeah, here also have one more. Oops. There's one more here. Yep, so this will also be the answer for part 2. Okay? Okay, then next part, part B, suggests why the drug samples P and T are found at different positions on the chromatogram. So why do they travel different distance? Is because they have different solubility. So do you have the word different solubilities? If have, then good, you get the 1 mark. If don't have, please do correction. Because remember just now I mentioned that for the RF value is like the distance they travel depends on how well they can dissolve. Okay, moving on. Next, part C. Explain why drug Q is still found on the start line. So why is it found on the start line? Again, same thing. It's about how far they travel, right? If you can't travel, that means you can't dissolve. Oh. That's why the answer is not soluble or insoluble. Please use proper terms. If you were to say that they cannot dissolve, nope, not acceptable. This is very talking term. Use proper terms. Soluble, insoluble. Yes, Jaden, you have a question?
Then shouldn't it be just Amy took drugs P, R&T, not drug samples?
You can just say drug. Anyways, the keyword I'm marking is the word different solubility. As long as you have different solubility, will do. Okay, so I shall move on with the lesson already. No worries. If you can't finish copying, as mentioned, I will be providing you the answer key at the end of the lesson. You can go home slowly and copy it down, like if you are writing slower. Okay, so I shall move on. No worries. I'll give you the answer key at the end of the lesson. Okay, so continue on to the notes. Okay, so done with separation technique. Let's now move on to the next chapter, which is the ray model of light. Can you all flip to page 19 now? Page 19. Okay, so for page 19 over here, on lights, you need to know that light is mainly made up of two sections, reflection and refraction. So for reflection, you need to know that there are two laws of reflection. So this one, by right, you all should know from school, right? Because teacher mentioned before. So let me just double check, since you all learned before, right? You should be able to answer me, right? So they said that the incident ray, reflected ray, and normal at the points of incidence. So let's highlight the point of incidence. The point of incidence is over here, where the light ray comes in. All lie on the same plane. What does it mean by the word plane? You learned this before in school, right? What does the word plane means?
Like a flat surface.
Very good. Flat surface, like a flat layer. Very good. Yeah. People, if not sure in school, must ask teacher. Yeah, you see, like teacher teach before, so by right you should be able to answer now. Yep. So what do I mean by that is, for example, if I were to say that maybe this surface over here, maybe it's like a mirror, for example, but this is actually my writing pad lah. Yep, so now I have a light that comes in, the incident ray, and then I have a light that reflect off, as well as the normal. So now if I look at this three light ray, if I turn it, can you see that they are all in the same layer? Yep, so that's what they meant by same plane. That means they are all in the same layer. Next, the angle of incidence and the angle of reflection are equal to each other. And whenever it's angle, it must be between what thing and what thing? Is it between like the surface and something, or what? So it should be between what and what? Between normal and the, very good. Yep, normal and the ray. So if it's angle of incidence, then it will be between normal and incident ray. If it is reflection, then it will be between the normal and the reflected ray. So take note, it's always between the normal and the ray, not the surface. Okay? Next, spelling of keywords. Please spell correctly. When it is the light ray that comes in, yeah, we will call it as incident ray. But when it's the angle, it's called angle incidence. Do you see the difference in spelling? So it's not called incident angle. Incident angle is wrong. You'll be marked wrong. Then likewise also, for the light ray here, it's called reflected ray. As compared to angle, it's called angle of reflection, not reflected angle. Reflected angle is wrong. Have you underlined the spelling? Yeah, so take note of the spelling. Yeah, underline it. Okay, then now let's label the angle. So angle incidence would be over here, right? Between the ray and the normal. Then for angle of reflection, also same thing, will be between the ray and the normal. So this would be the angle of reflection. Label. Okay, so moving on. Next part. Regular versus diffuse reflection. So now, I ask you, since you all learned before, I don't want to keep talking, you all answer me instead. Okay, so if I were to say that, maybe I touch here, the poster here, very smooth. Or maybe I touch my face, maybe my face very smooth. I keep applying Korean skincare product. Okay, so maybe the surface of my laptop here, very smooth. And then I touch the mouse here, like very smooth also, right? So for all these surfaces, like these 4 surfaces that I mentioned, is it under regular reflection or diffuse reflection? Which one is it? So I hear like mixture of answers are regular versus diffuse. So what's the answer? The answer is diffuse reflection. So sadly, actually my face is actually a rough surface. Why? Because if you zoom in microscopically, like the poster or my face or like the mouse, anything, you zoom in, right? Actually, microscopically, it is still bumpy. So how do you decide if it's regular or diffuse? Because the word smooth and rough very subjective, ma. Everybody has different degree of like that they consider as smooth. So what you do is you look at the reflected ray. If the reflected ray is parallel, similar to your object, that means you can see the image, correct? Because you see, the light ray from the image and the light ray for the object is exactly the same. That means you can see the image. So write down over here, please. Yeah, image can be seen. Are you all copying? Can you follow and copy down? Then as compared to diffuse reflection, you see, from my object is parallel light rays. But when it get reflected, it points like anyhow, anywhere. So this is called skewed reflected ray. So in this case, it looks different from the object, right? That means image cannot be seen. So you see, like if you look at the poster, you look at my face, do you see your own reflection from my face? You look at my mouse, do you see your own mirror reflection of yourself from the mouse? No, right? You don't see any reflection. You know? Image cannot be seen. That's why it's considered as diffuse reflection. Okay? Done copying, right? I shall move on. Next part, ray diagram. So for ray diagram, when you are learning how to draw ray diagram, actually, right, okay, usually school teachers like to teach it as like, oh, reflection, you draw this way. Refraction, you draw that way. But actually, it's not true. The way to draw for both reflect and refract, right, is actually exactly the same. Let me show it to you. So step 1, you always draw the image. And you know, right, image is always same distance. And I have a question for you again. You answer me. So for example, if I measure that for my object to the mirror example, it is 5 cm. So now on the other side, where should I measure my 5 cm from? Should I measure from the shaded line over here, like that, 5 cm? Or should I measure from the vertical line here, 5 cm? So that means both I'm measuring to the triangle tip. So where should I measure from? Option A or option B? Which one do you think I should measure from for the 5 cm? A or B? All right, the answer should be B, not A, okay? So you should, let's write it down. The top one is wrong. The bottom one is correct. Why? Because the shaded line is not the thickness of the mirror. The shaded line is to show you which side of the mirror it is. So that means like if the shaded line is on the right side, that means right side is the mirror side. Then the left side is the real world side. Okay? So then how thick is the mirror? The mirror is only this thickness. It's only this line, this thin, you know. This is the thickness of the mirror, okay? So always measure from the vertical line, not the shaded line. Next, how do you know how many light rays to draw? If the question did mention to you, okay, draw 1 light ray or 2 light ray, very good. You follow the instruction. But if the question never specify, what you do is you go by this. If they give you 2 eyelid, you draw 2 light ray. You follow 2 light ray. 2 eyelid means 2 light ray. If they give you as 1 dot, you draw as 1 light ray. Because when it's 1 small dot, it's impossible to aim the top and bottom of the dot anymore. So you just aim to the center of the dot. Yep, so that's why you draw 1 light ray. And next, arrow should point which way? Need to take note that arrowheads must always point into the eyes. because you're not superhero, okay? You don't shoot out laser beam, yeah, so you cannot have arrows coming out from your eyes. So light should enter your eyes instead. So it should point into your eyes. Can you highlight the arrowheads, please? Don't draw the wrong direction. Then each light ray should have one arrowhead. Next thing to take note would be that for the mirror side, you all learn that mirror has this characteristic, right? Start with letter V. What is it? Virtual, very good. So since mirror image is always virtual, that means it's not real. So not real, that's why you should draw everything in the mirror side as dotted lines. You know what virtual is, right? Like for example, like like Samsung, they have this like virtual reality goggles. So virtual means like you look at something that's reality, like you look at a forest. Then when you look at it, you feel that you are like in the forest, but you're actually not in the forest. It means it's like fake, like, so that means like fake real thing. So that means yeah, what you see is the forest, real forest, but you're not actually there. So it's like fake location. Yeah, so that's called virtual. Also, virtual means not real. Okay, so step one, what you do is you draw the image according to the same distance. So you measure if left side is 5 cm, right side you also measure 5 cm. This construction line over here, you follow what your school say. If your teacher say that, okay, construction line is compulsory, you draw in this dotted line. If teacher never say that it's compulsory, you don't want to draw, it's okay to omit. Then usually is that the same lines, we'll draw with same number of strokes. So these two same length, both are one stroke. Then the other two same length, two stroke. You can 3 stroke, 4 stroke also can. So after done drawing the image, step one, step two, you connect from the image to the eye. So the image, you connect to the eye. Then take note, mirror side, always draw with dotted line. Then now that your image connect to eye, do you realize they will cut through the mirror? So then in this case, there would be this point of intersection. Can you see? Where the light ray and mirror intersect. So what you need to do is, step three, you connect from the object to these 2 points of intersection. Connect from object to these 2 points of intersection, then done. So this would be how you draw your ray diagram. So ray diagram don't need to use protractor one. Just use ruler will do. Now, let me compare and show it to you. For refraction, the steps to draw exactly the same. It's the same 3 steps. So step one, it would be draw image. Let's take a look. So for refraction, you see over here, next page. Step one, draw image. Then step two, connect from image to eye. Do you see over here? Connect from image to eye. Step three, you connect from object to point of intersection. Over here, connect from object to point of intersection. Do you see that it's exactly the same steps? So actually it's not a totally different drawing. It's the same logic. Yeah, so what you need to do is for ray diagram, how you draw is you have to draw the object shallower. So take note, okay, that object always appears shallower than it really is. That's why if you do not know how to swim, don't anyhow jump into a swimming pool, because the swimming pool always appear to be shallower, but in real life it's much deeper. Yeah, so that's why only if you know how to swim, you can jump in without knowing the depth lah. But if you do not know how to swim, don't anyhow jump in. So since we know that the image always appears shallower, that's why you draw the image to be higher. So that's why you draw it to be shallower. And since this is an image, you always draw it with dotted line. Copy it down. Because in real life, there's only this one fish lah. The second fish over here, this is just an image. It's not a real fish. So since it's not a real fish, you cannot draw with solid line. So that's why it's a dotted line, because this is an image. Yep, so this is how you draw for your image. So step one, draw the image to be shallower. And can you try your best to draw them further apart? Because if you draw them too close together, right, later all the lines will be like overlapping with each other. Then it's like very messy. You cannot tell them apart. So draw further apart so that the lines are more distinct. Okay, then step two, you connect from the image to the eye. So can you see you connect from the image to the eyes? And you need to know that our eyes always believe that light travel in a straight line. So when you draw this, it must be a straight line. And because eyes believe that light travel in straight line. For the dotted line here. Label. Okay, then next would be that because your image is not real, it's dotted line, obviously this light ray here must also be dotted line, right? Because you know in real life that it is different material, water versus air. It cannot be a straight line. That's why this should be drawn in dotted line. Then lastly, it would be the real object. For the real object, it would be you connect from the object to the point of intersection. So likewise, your light ray just now and your surface, do you realize that they actually intersect over here? The surface and your straight line. Surface and straight line intersect over here. This would be your point of intersection. You connect from the object to this point of intersection. Okay, so so that's how you draw. Come, let's try out and see whether you know how to draw it. So if I were to, let me see. Okay, we directly look at the mock exam question. There's a similar question. Can you take a look at the mock exam paper, open-ended question 5? Mock exam paper, open-ended question 5. Okay, question 25. Yep, so let's take a look and see whether do you apply the 3 rules. So remember, what is step 1? Step 1 would be you have to, let me show it to you. Step 1, you have to draw the image shallower. So do you draw the image shallower? Oh, but anyways, the image you just draw like the fish, then just draw it shallower. Okay, so that's step 1. Draw the image shallower. Then step 2, what do? So you refer back to the notes. Step 2, you connect from the image to the eyes straight line because eyes always believe that light travel in a straight line. So that's why you connect from the fish to the eyes. Okay, you can connect to eyeball or eyelid. Both are acceptable. Okay, either eyeball or eyelid. Oh, no worries. I'll give the answer key later. Yeah. So you connect to the top and bottom, eyeball and eyelid, straight lines. Then done connecting straight line already. Then you continue on with step 3. Step 3 would be you connect from the object to the point of intersection. So that's why you see, you connect from the object to the point of intersection. Can you see the surface and the light ray, they intersect here? So you connect from the object to the point of intersection. Then lastly, do you have the arrowheads? Can you check? Do you have the arrowheads? And I told you, right, we are not superheroes. You cannot shoot out laser beam. So you have to receive the light. So the arrow should point into your eyes. Done. So this will be the answer. Okay, so I shall move on because if you have completed, I think if you just do correction or check your answer should be quite fast. If you haven't do this question, you can attempt it at home first. Then later I'll give you the answer key. You can check your answer again later. Okay, then next would be, so they are asking you that his companion, okay, the 2 drawing is covered above. His companion advised him to place his eyes at position X when aiming at the fish. Do you agree with suggestion? So position X is over here, which is directly above the fish. So is it recommended? The answer is yes. Why? Because when your light ray enters perpendicular to the surface, it won't undergo any refraction. So the reason is because, let me just draw out the explanation. Okay, so for those of you who haven't do this question, can you don't like busy copy the answer? I told you, I'll give you the answer key. You listen to my explanation. You copy down all this explanation better because the explanation, after I go through this, I'll clear away. But the answer key, you will have it at the end of lesson. So can you follow me and draw it in? So for example, if you have an object, then if your eyes is like over here, to view the object, do you realize that to view it is actually a straight line down? So can you draw a vertical line down? So once you draw a vertical line down, and next is if we want to draw in the normal, because you remember from school that normal is always 90 degree to the surface. So if I draw my normal, do you realize my normal and my light ray are stuck together? So if they are stuck together, what is the angle of incidence between the ray and the normal? What's the angle between the ray and the normal if they are stuck together? It's how much? How much is it? 0, correct. So if your angle I is 0, no angle of incidence, of course, no angle of refraction, right? That's why no refraction. Okay. Yep, so can you copy this in? Yeah, so that is why it is recommended to look from the top. So that there's no refraction, no bending of light. That means the fish is really at the exact spot. Yeah, it's not bent and become like shallower. Yeah, so it's still at the same place. Done. So that's what the answer key is trying to say. Okay, so I shall move on. The answer you can slowly copy when I give you the answer key. I'll continue on to the notes. Yep, so done for the ray diagram over here. So, oh yeah, just now I jumped a little bit, right? I was actually going through this. Yeah, then I jumped to the refraction page. Okay, since we also went through on this drawing, let's also take a look at how do you do the drawing for reflection. So reflection would be one page in front. So can you take a look at question 24? Okay, so for question 24 over here, so remember I told you first step is you always, step one, what do? You always draw the image. So do you draw the image to be equal distance? You have to count how many boxes? 5 boxes. Then the other side, remember, count from the vertical line. Then count from vertical line, 5 boxes. Then remember, image is always virtual. You draw it with dotted line. So that's step one. Moving on to step 2 would be you connect from the image to the eye. So if you want to connect from image to the eye, you choose a point. This time around, did they mention which point? We never mention which point. Then you can just pick a point that you prefer lah. So any point also can. So this time around, they pick over here. So you connect from the image to the eyes, straight line. And likewise, you want to connect to the top and bottom eyeball or eyelid also can. But not to the pupil. Okay, so it should be to the eyeball or eyelid, not pupil. Then after you connect, remember, mirror side is always virtual. So you draw with dotted line. Then you finish up by including the third point. So step 3 would be you connect from the object to the point of intersection. So the object is over here. Can you see that the light ray and mirror, they intersect over here? So you connect from the object to the point of intersection. Yeah, then lastly, remember arrowhead always point into the eye, because you're not superhero, okay? You cannot shoot out laser beam. Yeah, so you should point into the eye. Then done. So this will be the answer. Okay, so likewise, I will move on, sorry, because time is very tight today, so I don't really have much time to keep on pause here to let you copy the answer. So no worries, I'll give you the answer. Okay, let's continue on. Oh wait, where's my notes? Over here. Okay, next part, it would be characteristics of mirror images. So there are 3 types. Plane mirror would be the straight mirror which you see above. So plane mirror is this kind of straight one. Convex mirror versus concave mirror. Both are curved mirrors. But how do you know which side is the reflecting surface? So how you can remember is, if you were to say that you go to a cave, if you go to a cave, isn't a cave like dent in this way? Right? Cave is usually dent inwards. Yep. So in this case, since you're going into the dent in part, we would say concave mirror, the reflecting surface, it would be this surface. So this is the reflecting surface. This is inside the mirror. So convex would be opposite. Convex would be the light ray should actually shine from the other side. Then this would be the inside of the mirror. Okay? So you just remember cave. Cave is like, going to a mountain cave. That's why light goes in at the dent in part. Then convex will be opposite. Done copying. I'll move on. Yep, so quickly follow and copy it down. Next, need to know the characteristic. So for plane mirror, I think you all should know what it is already. I don't want to go through anymore. By the way, you all know what's laterally inverted, right? What does it mean by laterally inverted? What's laterally inverted? Like left become right. So that means if I raise my right hand, if you all are my mirror image, you all should raise which hand? This is my right hand. You all should raise your left hand. Okay, so that's called laterally inverted. Means left, right, flipped. For convex mirror versus concave mirror, it would be that one enlarges the image, one becomes smaller. So when do we use concave mirror? Concave mirror would be usually used in some hotel toilet mirror. So sometimes if you go to those like very high class hotel, while you're traveling, yeah, then you might see such mirror. Let me show it to you. This kind, can you see this kind that can move around one? Yeah, so usually if you go and look at it, right, if you go look at it close up, it's magnified. Why? Maybe you have an acne, you want to like squeeze or what, and then you can have this magnified mirror, you can see it clearly. So this is one example of a concave mirror. Another one would be like, for example, you want to maybe the dentist want to see whether got any tooth decay, so need to amplify and make it bigger, right? Dental mirror. or car headlights. You know, cars at night on the road, when they on their headlights, best is as bright as possible so that you can see the roads clearly. That's why it's better to magnify the light so that you can see clearly. Then for convex mirror, it will make things look smaller. So when do we use it? It would be in like car park. Yep. So if you were to look at this, I think you've seen before. Did you all see this before, like in car parks and stuff? Yeah. So all these, why do they use a curved mirror? The reason is because it allows your image to be smaller. Smaller means one mirror, I can fit in a lot of vehicles. That means I can see like more parts of the road and I can see more vehicles. So that's the purpose, lor. For wider field of vision. Okay, so that's what I showed you just now. Installed at the blind spot of the road. Last time in the past, when they have CCTV, then yeah, like 7-Eleven, they will install this kind of mirror so that they can see the whole shop in just one mirror because everything becomes smaller. Done. Okay, so yeah. Let's move on. The next part over here on refraction. So need to know that why light will undergo refraction, bending. The reason is because they enter material of different densities. So once it's different density, then there will be a bending of light. The law of refraction, the first one, it would be similar to your reflection, right? So nothing new. Second one is just, if your school did teach this, then you just remember. For now, I won't explain because this concept of the sine I and sine R is more for upper sec. Yeah, and then now with limited time, so I won't go through in detail. Yeah, so this one just need to remember. Okay, next part over here. Come, I have a way to help you to remember, to make your life easier. Which is, okay, if you have light traveling from less dense to more dense material, just to check, if you were to be at a place that is less densely populated versus you go to a place that is more densely populated, that means crowded, how would you be able to move? Would you be able to move faster or would you be able to move slower? So you move from a less densely populated place to a super densely populated place. What happened to your speed of movement? How can you walk? Will you walk faster or will you be able to only walk slower? Slower, right? Because very crowded, right? Usually when very crowded, you can only inch behind the crowd, correct? So that's why when you go to a denser medium, your speed of light would be slower. Okay, right now, that's why speed of light decreases. Next, if you were to go from densely populated place to less densely populated place, isn't it going to a less crowded place? That means now maybe not crowded until, wow, I can even run. So that's why your light would be able to be faster. And then I have this mnemonic for you. It's called fast. Yep, so what does it mean by fast? Okay, write down F-A-S-T. So F-A-S-T means light will be faster when it bends away from normal. Are you copying? Copy down. And light would be slower. Can you see letter S? S would be towards. Yeah, so that's how you can remember all that. Bend towards or bend away. Because after a while, sometimes, like you keep memorizing it, you might get confused. Yeah, then sometimes, exam stress, and suddenly, like, yeah, I know that I got study, but just blank out. Yeah, so you can use this mnemonic to help you. So faster will be away. Slower will be towards, okay? F-A-S-T. Okay, so for the light ray, what you do is you extend it out. So can you see that right now, the light is going nearer to the normal? So this is called refract or bend towards the normal. So you always base on your original light ray. So over here also I extend it out. So when I extend it out, do you realize that my normal is here? But my light ray goes away from normal. So this is called refract away from normal. Done. That's all for the annotations here. Everyone done copying? Yep, so copy down all the annotations. Once you are done copying, can you take a look at the MCQ question number 12? Those of you who haven't done it yet, can you try to quickly do question number 12, MCQ now? MCQ question number 12. Okay, so I shall review the answer for question number 12 now. Okay, so the answer for question number 12 is D. You get it correct? Okay, come, let me go through this. Okay, so for this question here, so you check, you see, this time round, can you tell that my original light ray is like that? So what happened is that your light ray now actually bends away from normal. Can you see? Because your light ray is going away from normal. So if it bends away from normal, remember we said it's F, A, and S, T ma. Away means it is traveling faster. Faster means this is less crowded, correct? So that means this should be denser, while below should be less dense. Do you agree? Then now we look at the next two. This time round, if you extend out the light ray, so once you extend out the light ray, can you see that the light is actually going nearer to the normal? So if it reflects towards the normal, that means it should be slower. Slower means you are moving to a denser medium. And next is, can you see the refraction is so much more than the above? So the greater the refraction, the greater the difference in the density. Okay, so let's write this in also because this is important. Let's write it inside the notes. So take note that the greater the density difference, we can copy it down in notes page 20. Notes page 20. Yep, the greater the, oh yeah, and this topic is light. Use the word optical density, okay? So the greater the difference in optical density, with my English a bit broken. Like that. Yep, the greater the difference in the optical density, the greater the refraction. That means they will bend more. Yep, write it in notes page 20, copy it down. So now if we were to compare it to this question over here, we done copying my none, right? Yep, so based on this part here, now we know that, you see this one, the refraction is the most, that means R will be more dense than the top one, which is P. Okay, because both are dense, then P and R are dense, but R definitely more dense. Then Q would be the least dense. So you just choose the correct option. So answer will be C. Okay? Okay, then let's continue on to the next part of the notes. Okay, so this part I went through already just now. I'll move on. Dispersion of light. So you need to know that because light will undergo refraction when you pass through material of different density, that's why in this case, the light will bend. And how would they bend? How to remember? I believe usually school teacher will just tell you, okay, must remember, red light travel the fastest, refract the least, longest wavelength. But how to remember? So usually at tuition, that's how I teach my students, which is I always teach them tips on how to make their studying life easier. So I'll go by this. You see, for rainbow, you always know that rainbow is red color on top, purple color below, correct? You all seen rainbow before, right? And so if red is on top, that means, do you realize they bend less compared to purple? Purple, they bend more. So why do red bend less? Is because they travel inside the glass very quickly. So if you pass through the glass very quickly, it's like my glass particle don't really have time to refract the light. That's why it refracts the least. Compared to purple, it would be that because they travel inside the glass also. Or if you travel so slow, that means I got time to keep on push you, right? That's why you got time to keep bending the light. That's why if it's traveling slowly, you can refract more. Does it make sense? Then next is how to remember the wavelength. Okay, what's wavelength? Wavelength is the length of the wave. So light is actually in the form of wave. There's a lot of things that is in the form of wave, like sound. Sound is also in the form of wave. You know your microwave to reheat your food, microwave oven, and microwaves are also wave. Yeah, so that's why it's just the length of one wave. So now, if I say that, okay, maybe I fix a period of time, maybe I fix it in 1 minute. In 1 minute, if you can run very fast, what's the distance you cover? Would you cover a large distance or small distance in the same time duration of 1 minute? You cover a large distance, right? Because you can run very fast. As compared to this, in a fixed time of 1 minute, but if you run very slow, wouldn't the 1 minute you only cover a very short distance? That's why you know, short distance, short length. As compared to this, you run very fast, you cover a large length, a longer length. Yeah, so that's why greater length. So longest wavelength. Okay, so that's how you can remember. Yeah, so don't need to memorize by heart. Like, if you understand the logic, yeah, there are tips and ways to remember. This one I think you all should know lah. Once you flip it, it will be convert back to white light. Then over here, good to know of the applications of the common electromagnetic radiation and its effect. Okay, come. Let's take a look at MCQ question 13 on colors. Okay, you all flip to MCQ question 13 now. MCQ question 13. Are you all done with 13? If you're not done, can you quickly read through the question and see what do you think is the answer for question 13? I will review it soon. For those of you who are done with 13, you can take a look at the answer here. Those who are not done, can you try to quickly finish it up? Yeah, if you are done, you look at the screen. If you're not done, you finish it first. And so what you need to do is you just compare with the notes to see the position. Okay? So you can go by like what you understand from rainbow color lah. Red is on top, purple is below. Then eventually they will all combine back together to form white light. Okay, so this will be the answer. So answer is C. Okay, so done for light. Okay, then next, let's move on to the... Oh, wait. I think light, I still have one more question. Question? Wait, let me check. Did I go through everything? 11. Have I went through 11? Haven't, right? Okay, come. Can you check your answer? Answer is 40. Okay, so how to get the answer? Let me go through. So what you need to do is angle. Remember, I told you angle must always be between where and where? What did we write inside the notes? Can you look at your notes? Correct, thank you. It's always between the normal and the ray. So always make a good practice to always join normal. Once you're lazy, you never join the normal, right? You're careless now. So always make it a habit. Okay, so remember, for today onwards, always join the normal. Once you join the normal, more likely you can get the correct answer. So you draw the normal in. So your angle of incidence, it would be over here, right? Because I based on the original lah. So this is the angle of incidence. So what's the angle of incidence over here? You can tell? What's the angle of incidence over here? What's the angle of incidence over here? Anyone? Yeah, correct. Because you take 90 minus 25, then you get 65 degrees. Yep, so that means actually your angle of reflection over here, how much is it? What's the angle of reflection? How much? Yeah, correct. It's also 65 degrees. Okay, then now they said that they tilt the mirror to be 25 degrees from the original position. And they ask you what's the new angle of reflection. So now, if you were to tilt your mirror, will the normal get tilted? Yes, right? The normal also get tilted. And the normal get tilted by the same direction, which is you go like clockwise by 25 degrees. Yeah, so that's why now my new mirror here, this would be the new normal. Okay, wait, I can't really draw a... I see two sideways on from the TV is something like that. Is it? Is my line 90 degree to this line here? Does it look 90 degrees? Cannot really see, sorry. I see two sideways from the TV. Okay, so okay, what I'm trying to draw is I'm trying to draw a 90-degree line to this new surface. Okay, so I'm trying to draw a 90-degree line to this surface. So can you draw your 90-degree line? I can't draw it well because I'm sitting two sideways. So you draw a 90-degree line to this mirror. So now your normal will rotate by 25 degrees. So now that your normal rotate by 25 degrees, so what happened to your angle of incidence? Can you see that the angle of incidence now became smaller? You see, just now my angle of incidence was big. Now it became smaller. So that means now my new angle of incidence became smaller by, can you see this part here? Which is 25. So my new angle of incidence became smaller by 25. So what's my new angle of incidence now? Smaller by 25, right? That means you minus 25, you'll get 40 degrees. Correct? And then based on law of reflection, since angle I always equal to angle R would be how many degrees? How much is angle R? 40 also, right? Because law of reflection says that I is equals to R. Yep, then done already. Also, the answer will be B. This is the new angle of reflection. So this is for the new one. Then the blue one, it will be for the original. Yep, so done for the chapter on light. Okay, then let's move on to the next chapter, particulate nature of matter. So particulate nature of matter is page 24. Okay, so for this topic here, you need to know about kinetic particle theory, that particles are always in constant random motion. This is very, very important. Because later when we answer questions behind, we will actually link back to this point again. Particles are always in constant random motion, meaning they are moving non-stop, constantly moving non-stop. Random meaning in terms of direction. They can move in any random direction. Highlighted and copied down already. Can you follow and copy it down, please? Copy it down. For the first 4 row, I'll leave it to you to study on your own because the first 4 row you learned before in primary school already. I'll move on to the secondary school part, which is over here. The forces of attraction, arrangement, and movement. So need to know that for the arrangement, I go through arrangement first. Arrangement is actually about how you draw the particles. So it's a drawing of the particles.
Miss, where is the part for? Is there like missing notes for cells?
Because for online copies, I only give you the 3 chapters that I'm teaching. Yeah, so if you want the full set of notes, that means from the first chapter to the last chapter for the Sec 1 syllabus, you have to collect the hard copy of the revision kit. Yeah, so you can actually visit any of Overmark centers to do the collection.
As in like the physical like center.
Yeah, so Overmark, we have the 5 branches. You can visit any of the 5 branches to collect. But to be safe and make sure that whether still got stock or not, because it's like yesterday we distributed a lot, then it's like while stock lasts. Maybe you can actually contact Overmark hotline to ask them whether like is there stock before you go down so that you don't make a wasted trip.
Okay.
So for Bukit Timah here we still have stock. Yeah. Okay, so for the drawing, so for solid, as you can see, you need to draw them very close together in an orderly arrangement. So you draw them in neat rows. And things to take note when you draw. Number 1, if this pen is a solid, right? Any solid that I let go, what happened to the solid? It will drop, right? So that's why when you draw for solid, make sure that you must touch the bottom because all solid will drop. So can you highlight it? You also make sure that you must touch the bottom because all solid will drop. Okay, then next would be for liquid. It is packed closely together. Don't have the word very anymore in a disorderly arrangement. So can you try to draw it like a bit like, messy a little bit? Don't draw like clear rows. And next is for liquid. Like for example, if I look over here, do you see that water always touch the bottom and the sides of the container? So that's why when you draw for liquid, you always draw them touching the sides and the bottom, just like how liquid in a bottle or cup behave. Highlighted. Highlight it. And next is for liquid. Do you realize liquid surface is usually horizontal? So when you draw it, can you don't draw the particles until, some of my students like to draw that. Then what, you mean your water level is zoom, go up? Cannot be, right? Water level don't go up. Water level usually is horizontal. So when you draw it, try to draw it kind of like, horizontal. Yeah, don't need to be really perfect horizontal, but kind of horizontal. Yep, then make sure they touch. And like for this particle here, make sure you have one more particle below to support because the liquid don't float. Yeah, so you need to have like another particle here to support. And next is for gas, it is far apart in random arrangement. To prove that it's really far apart, right? You really need to draw it. Some of them touch the sides. Don't need all, okay? Some touch the sides, some don't need touch. To show that, yeah, it's really very far. Far until I try to touch the sides to be as far as possible. Highlighted. Highlight it. Okay, then next would be the movement. I think you all know what movement is lah. So movement, you use words like vibrate, move, move. Next, the forces of attraction. Forces of attraction is always linked to the arrangement. Because if it's very close together, that means it will be very strong, right? But if the attraction is so strong, they will be stuck together, that's why they will be very close together. If the attraction is weak, then not attracting, that's why they would be far apart. Does it make sense? Yeah, so you can remember it together. Next, you can remember movement and energy together. For example, if the particle just vibrate, you realize it keeps on vibrate at that spot. So it's like not moving away. It's like not much energy, right? Because it keeps staying in the same position. So vibration considered to be low energy. As compared to moving at high speed. You know those like 3-year-old kids, wow, they always got a lot of energy, right? Keep running in the shopping mall and all. So yeah, if you have a lot of energy, high energy, that means the particles will be at high speed. Then lastly, it would be the drawing. So just now I emphasized to you some key points already. The remaining key points would be like for solid, minimally, you must draw 2 rows, and then it must touch like the bottom. Then for liquid, okay, for all of them, because okay, I know that recently it's like Olympics, right? But don't draw the circles to be overlapping like Olympics, okay? Make sure the circles are not overlapping. So just to let you know which are some of the answers that cannot be accepted. So these are the drawings that I see among my students also. They draw like that. Can you see like overshot? Like that. Cannot overshot. Must be really perfectly nice. Next is, oh, I got some student who are very artistic, trying to get like a perfect circle using brushy line. This kind also cannot. Okay? Then maybe the line, overlap a tiny bit, lazy lah. Okay, never mind. Also cannot. Okay, so all these are the incorrect ones, not accepted. You must really draw it properly. If cannot, just erase. Do it in pencil, then can erase it. Okay, so done. That's all. I shall move on. Done copying, right? Next part on diffusion. Okay, so for diffusion, you need to know that it is actually the net movement of particles. And what does it mean by the word net? Net over here means overall. You know, for example, right, like if you go shopping, then maybe you buy clothes, then there's some discounts. So the price that you pay is actually called the net price. So net price is the price after discounts. Yep, so it's the overall price that you include the discount also. So now I have a question for you. You know, usually MCQ, they will have this kind of statement, like, you know, they give you option 1, 2, 3, 4. Which of the following statement is true, correct? This kind of MCQ question. So maybe if I give you one of the MCQ option, you tell me, is this true or false? Particles. Can you copy it down also? So you tell me, is this true or is it false? You know, like MCQ got option 1, 2, 3, 4. Yep, so this is maybe one of the statement. Then they ask you select the correct statement. So which of the following statement is true? So do you think this statement is true? Yep, so after you copy it down, then you think about it. Yushen, do you want to copy it down? Yushen? Yeah, copy it down. Okay, so class, what's the answer? Is this true or false? Wrong. The answer is true. Why? Okay, so the answer is true. Surprise. Okay, so good that you are here. Okay, the reason is because of the word net. If I say that the net movement is low to high, then it's false. This is true. Let me write for you the false statement. So, net movement of particles is from low to high, then wrong. Okay, so this one is then wrong. Why? The main difference is because of whether is there the word net or not. Do you realize over here, no net? Okay, how come the net plays such a significant role? What's going on? Okay, you copy down first. After you're done copying, then I explain to you. Okay, so for this part over here, right, is that if we were to say that particles move from low to high, why is it correct? The reason is because of the kinetic particle theory. What did we say? We said that particles are in constant random motion. And what did we label just now? We said that the random is in terms of what thing? Can you check the previous page? What did we write? Random is in terms of direction, right? Because particles don't have eyes, what? How would particles know where they move? They just anyhow move everywhere, right? So that's why particles can move from high to low. It is possible. Just that as long as you look at them in terms of net overall, as long as it's overall high to low will do. But it is still possible that there are a few particles that move in the opposite direction. So that's why if you don't have the word net, this is still possible due to let's write down, due to the kinetic particle theory.
Wait, I have a question.
Yes.
Can you also write particles move from high to low concentration?
Can. Because
Okay.
particles move in random direction. So can be high to low, low to high.
Okay.
Yep, so can you write it in? Oh no, I no space. Let me try to squeeze it in. Oops. Okay. Can, because of the constant random motion. Copy it down. Okay, so what do I mean by this? Okay, let me draw out a diagram to explain to you. Okay, so for example, right, I have this case where I have like maybe a partially permeable membrane. So now I have like particles moving like this. So can you see that the left side has higher concentration? Let me ask you again. Hopefully you can get it right this time round. So if I were to draw it like this, can you tell me if my drawings are correct? So how is my this drawing correct or wrong? What do you all think? Is this drawing correct or wrong? Can you also follow and draw it in, please? Draw it, draw it. So how important is what you all think? Is it correct or wrong? This drawing is correct, okay? Why? Because again, you must always look at it in terms of overall. So I have three particles moving from high to low, correct? One particles moving from low to high. So if I look at them net, if I look at overall, it is still two particles moving from high to low. So as long as net overall is high to low, this is diffusion. Okay, because I told you before, particles don't have eyes. Sometimes they can go in the opposite direction or they can move within their region also can. They do not know where they are moving because it's random motion. Yeah, you just look at net. Overall, it's still high to low, means it is correct. Okay? Okay, so then, yep, so particles will keep moving, moving, moving. Move until when? They'll move until when equilibrium is reached. What is equilibrium? What does equilibrium means?
It's equal.
Equal in terms of number of particles or what?
The concentration.
Correct. It's concentration, not number. Yep. So you have to look in terms of concentration. Use the correct term, concentration. Okay. So now I have a question. Once it is equal in concentration, example, both sides the concentration is the same. Does it mean that the particles stop moving? Does the particle stop moving? Okay, correct. The particle do not stop moving. The particle still moving. Why? Because again, it's linked to the kinetic particle theory. Because particles are always constantly in motion. So even when you reach equilibrium, the particles are still moving. My next question is, when you reach equilibrium, right, is it possible for the particles to still pass through the membrane? Is it possible for particles to still pass through the membrane even when you reach equilibrium? The answer is
Yes.
correct. Can still pass through the membrane. Because again, it's random. Yeah, they do not know where they are moving. So if one particle were to move to the right side, then another particle will move to the left side. So it will always be equal in number. So that means like once you reach equilibrium, if two particles pass through the membrane, then there will be another two particles that pass through the membrane. So overall, it will still be equal in concentration. Yes, Sophie, do you have a question?
Yeah. For when they're equal in concentration, why is it not that they have the same number of particles?
Okay, because concentration is about the number of particles in a unit volume. So for example, if I were to say that maybe here, okay, so I go by same number. Okay, so maybe I have 3 dots. And then the other side also have 3 dots. But the thing is, if I were to look at a volume this big versus a volume this small, so now if I just if I compare it, do you realize that maybe for this region here, okay, how to say? Wait, I think my drawing, I need to modify a little bit. This particle, I draw it a bit higher. Okay, so if you were to have like a volume that is different, like here and here, do you realize that if I look at this part here, this part here has different number of particles, although they have the same number of particles. So that's why we always look at them in terms of concentration, because you need to take into account the volume. Because for example, if you have 3 particles, but if my volume is so big and versus so small, it would affect the concentration. Something like if okay, for example, right, like human. If I got 3 human on one MRT cabin, it is not crowded, right? But if I have 3 human, I ask them, you stand on one square. Isn't it very crowded? Then most likely they don't want to stand there, but they want to like, I want to quickly move away. Why am I like touching your shoulder so close together? So same for particles. So if they are so close together, even though also 3 particles, they want to move away. As compared to 3 particles that are far apart, okay, they'll just be relaxed in their own corner. You get the difference between concentration and number.
So what's like the definition of concentration?
Definition of concentration is the number of particles per unit volume.
Okay, thank you.
No problem. Okay, then yeah, so take note, okay, for equal concentration over here, let's write down the 2 questions that I was asking you just now. So take note that, okay, particles are still moving, they don't stop, okay? They are still moving because of the kinetic particle theory. So particles can still pass through the membrane. Yeah, so even when they pass through the membrane, but it will be in equal amounts, equal rates. Yeah, so that means if 2 particles move to the right of the membrane, then 2 particles will move across to the left of the membrane. Clear? Yeah, so don't get tricked. But this kind of question is always in the MCQ kind, you know, like they ask you, like, choose the correct statement or which statement is false. You also need to know that particles still moving, okay? Okay, so moving on to the next part here. So if question were to ask you to like, explain on diffusion, same thing, there's answering technique here. Please go and study, okay? This is like the model answer, model template answer. You copy and paste it in for exam, then you can get full marks for the explanation answer. Yep, so you need to mention about the word net. Very important, Yep, so you can mention maybe like it's like from the maybe sugar solution to maybe the cell, something like that lah. So you just fill in the blank according to the context of the question. Okay, then next would be the factors affecting diffusion. So for factors affecting diffusion, it would be number 1, the mass. Take note of the correct terms to use. The correct term to use is, you should tell me that is of higher or lower relative molecular mass. Use the full name, don't just say mass. Okay, so if exam, you just say that, oh, it's lighter, it's heavier. No, teacher won't give you the mark because keyword is missing. So must use the proper term, relative molecular mass. How do you know what's the mass of the atom? Do you know how to tell how heavy an atom is? Or how heavy any particles is? You can actually check the periodic table. So if you check the periodic table, right, it's actually the bottom number in the periodic table. Okay, so this how to remember, you need to know that when the particle is heavier, like greater mass, the rate of diffusion is lower. Rate over here means the speed. Yeah, because after all, diffusion is about the movement, so it's about the speed that they move. So if it's heavier, they'll move slower. Something like, okay, for example, if I have 2 men who are both not athletic, then obviously, if I have one fat man and one skinny man, who will move slower? Who will run slower? If both are not non-athletic, I give them 100-meter race. Fat man and skinny man, who will run slower? Generally, it will be the fat man that runs slower, correct? Why? Because he got more fats to carry, right? So that's why it's harder to run. Yeah, so fat man will run slower. So that's how you can remember. Next, answering technique again. So please go and study, okay? So when question asks you like to explain why a particle that is of greater mass like will diffuse slower, then you use the keyword like relative molecular mass and diffuse slower. So these are the keywords. Okay, then this is the first factor. Done copying, right? Okay, so moving on. Yes. As in like I'm saying that when you write as a sentence, how to like explain, you should use words called like higher mass, higher relative molecular mass, or lower relative molecular mass. You cannot just say that it's lighter or heavier. If you write lighter or heavier, teacher won't give you the mark. Is that how do you know what's the mass of the particle? You flip to the periodic table page. No periodic table, the number on top and below got number, right? And the below number is actually the mass of that particle. Yeah. Okay, then moving on to the next part over here on temperature. So temperature increase, speed of movement will increase. Why? Something like, example here, you don't really see the water moving. But if I boil it, you realize, wow, the water moves very vigorously, right, when it's boiled. Yeah, so that's why when temperature is higher, diffusion would be greater. Yeah, because it will move faster. And need to know that temperature is related to kinetic energy. Highlights. Temperature is related to kinetic energy, right? Because if the water is hot, you'll move faster. And movement is related to kinetic energy. The same thing, answering technique again. So if they were to ask you to like explain like why when it's hot, then it will move faster, why it diffuse faster, then same thing, remember that temperature definition is always linked to kinetic energy. Yep, so when temperature increase, you must mention about kinetic energy, and then when they move more quickly, that's why in the end, diffusion will be faster. Done. So this is the model answer. Come, let me test you, see whether you understand what I'm teaching so far. For example, right? Oh no, not stomach ache. Then, oops, I got sensation. Oh, I think I want to fart. Okay, so for example, if I feel that I want to fart, but then oops, I paiseh, got so many of you here, and somehow a lot of you I first time see you all. So I don't want you all to smell my fart, for example, okay? Then I brought my perfume here. So I'm hoping to, okay, when I about to fart, I spray at the same time. Okay, then now my question is, okay, assuming that my fart and my perfume has the same mass, okay, for example, both are the same mass. So if I do both at the same time, I fart and spray at the same time, which one do you all think you will smell first? Which one do you all think you all will smell first? The fart or the perfume? Yeah, you will smell the fart first, sadly. Why? No, I think I spray quite high concentration. I can keep spraying, right? To have very high concentration. So why? Higher temperature, correct. My body heat is how much? 36-ish degrees Celsius, right? Then the perfume is at room temperature. Here is aircon room. Then maybe like 20 plus degrees Celsius. So obviously my body temperature is higher. So higher temperature, diffusion will be faster. So that means in a way, if I want to cover the smell of my fart, what should I do for my spraying? I should spray earlier because my perfumes travel slower. Yeah, because higher temperature fart would diffuse faster. Okay? Okay, so let's continue. Okay, so then for the wait, before I continue on, let's go through some of the questions in the mock exam paper. Let's take a look at question number 7 of the MCQ. Wait, no, not 7, sorry. Question number 17, sorry, see wrongly. So question number 17, answer is A. So take note, okay, that whenever you have not only compression, even for expansion and contraction, it is always about the distance between the particles that changes. Yep, so that's why the answer is A. So the particle size will remain the same, that's why the mass is the same. Yep, then when you compress, then the arrangement still follow. Like if it's solid, it's still regular arrangement. If it's gas, it is still random arrangement. So that's why the arrangement won't change. Okay, so next question will be question number 16 also. Oh yeah, 16 you'll go through. 16 is for this topic. Question 16 here. Anyone need me to explain to you how to get the answer of C? So you can get it right? I think it's easy lah. Okay lah, then I move on. Okay, so 16, 17 done. Moving on to 18. Answer is B. Okay, so for this question here, they're asking you which of the following explain the change. How come like both sides looks like the same color? It's because particles are always in constant random motion, right? They'll keep on move and move and move until they reach all part of the container. That's what we meant by diffusion also. Yeah, so answer is B. Then take note that over here, both particles will diffuse. That means oxygen will have a net movement downwards because diffusion is from a region of higher concentration to lower concentration. Bromine also will also diffuse upwards. Yeah, then bromine will also move from high to low concentration. And if you're wondering in terms of the speed, how to know who diffuse faster or slower, you can go by the periodic table mass. So if you check periodic table, what's the mass of oxygen? What's the mass of oxygen in the periodic table? Oh, yeah, you don't have periodic table, right? Okay, then I'll just tell you. Or maybe where have the periodic table to flash to you? Never mind lah. But anyways, if you check periodic table, the bottom number of the periodic table is 16. For bromine, if you were to check right over here, you check periodic table, okay? So based on periodic table, oxygen mass is 16. For bromine, shucks, I cannot remember. Bromine, the mass is, okay, in the end, I think I still need to open periodic table. Let me open the periodic table. Hold on. Okay, so for oxygen and bromine, they are here. So you see, oxygen is 16, bromine is 79.9. Oh, sorry, my periodic table is the IT upper sec version also. Yeah, that's why I got decimal place. So just based on 16 and 80. Okay, so based on 16 and 80, let me write it down. So mass is 80. Yep, so can you see that bromine is much heavier? So if bromine is heavier, that means bromine will travel faster or slower? Heavier, like fat man like that, right? Fat man will run. Fat man, run faster or slower? Slower, right? Yep, so that's why that's why you all choose oxygen diffuse faster. Okay, understand. Okay, but the thing is that is if you say diffuse faster, it's more of like maybe you can say that like the brown maybe until here. Yeah, so if the brown like travel up very slow, then yeah, you write this. But this time around, they're asking you to explain this change. So you know MCQ, true that both B and D are true, but to explain about this, the spreading out throughout, B would be a better answer. Because D is about the speed. But the thing is that over here, you can't really see the speed of it, right? Over here, what I see mainly is bromine spread out. So if you want to write, also write as bromine travel faster, because you can see the bromine spread out. Yeah, but you can't see the way the oxygen move. That's why this is true, but not possible to tell from diagram. You can't see from the diagram who is faster and who is slower. Only through calculation then you know. But it's not explaining about this change. And also not explaining the change. Okay, so that's why between B and D, B would be a better answer. Okay, so I shall move on. Done copying, right? So people, make sure you write in the explanation because explanation is not in the answer key. My answer key is just, legit answer key. Yeah, so all this explanation, make sure you copy it down. Okay, then moving on. This one, don't need. Okay, then let's continue on with the notes because I haven't finished the chapter yet. Oh yeah. Okay. Then next part over here, change in state. Okay, one thing that I wanted to emphasize to you is that when you heat things up, like over here, when it's undergoing condensation or freezing, when there is contraction or expansion, you need to take note that it is the spacing between the particles that changes. Yep, so maybe let's write it down. During contraction and expansion, the particle size don't change. Why? Because, okay, for example, I write expansion first. Expansion easier to explain. So during expansion, you need to know that the particles actually gain thermal energy. And when the particles gain thermal energy, that means they will move more vigorously, right? So if they move more vigorously, that means they will like push their neighboring particles away. So if you push the neighboring particles away, isn't it means that the spacing between the particles increases? Yeah, so that's why we would say that during expansion is that the collision between the particles increases such that the particle spacing increases. Yeah, like that. Okay, let me write it out. Hold on, give me a while. A bit hard to walk though. Maybe after class instead. Can? Okay, so yep. So let's write this down. So you need to know that particles would like vibrate for solid or move more vigorously or move faster. So only when because they move more vigorously and faster, that's why the distance increases. And then the distance between the particles, I write properly, distance between particles increase. That is why the spacing increase. So take note, okay, that the particle size itself do not increase because particles are always microscopic. That means they should always remain small. Yeah, so particles will always be microscopic. So even you heat or you contract, the particle size don't change. It is the spacing between them that changes. They need to write more complete. Okay, so okay, for me, because like whenever I teach my students mostly from like NYGH, so the teacher actually, school teacher emphasize that cannot just directly say spacing. You need to mention that, oh, because you need to, they move more, then collide more, then become the distance increase, then spacing increase. So like this is like the more complete answer. Then for contraction, it will be likewise, like just opposite. So instead of vibrate or move more vigorously, you change to less vigorously, decrease. The answer is the same. Okay, so I think contraction I shall not write anymore. It's just directly opposite. Next, for this kind of graph, need to know that whenever it is slant line, it is only one state. When it is a horizontal line, there will be two states plus processes happening, like boiling, freezing, melting, condensation. Copy it down. So in this case, as you can see, the diagonal lines, they only have one state, like liquid only or solid only. Then when it's horizontal line, there will be two states. Come, let me test you, since you all learned this topic before. If I want you to draw the middle section, the drawing, do you know how to draw it? Like over here also, if they ask you to draw the center drawing, like draw the arrangement of the particle, how do you draw it? Do you know how to draw? How to draw? So if it's like gas and liquid, how do you draw it? So, okay, if it's got gas and liquid, let's decide who is on top and who is below first. So which one most likely will float on top? Is it gas or is it liquid? Gas will likely to float on top, right? So you draw the gas on top. Then you draw the liquid below. Then liquid, you try to draw it such that it's irregular arrangement. Yeah, like that. So this will be how you draw for the center region. Copy down. Hello, people, draw it in. Then if it is liquid and solid, same thing. Who do you think is denser and will be at the bottom? Which one? Solid, correct. So you draw a solid at the bottom. And one hint is, why not you draw bigger? You draw bigger, you can draw less particle, right? Also draw bigger lah. You draw bigger, then you can draw less. Then after that, on top then start to become liquid. Then now you start to have irregular arrangement. Yeah, like that. So can you see below solid, on top liquid? Okay? Okay, so just to let you know, my notes over here, right, the three column represents the three section of the graph. Can you see? First section is first column. Second section, second column. Third section, third column. Okay? Then both graphs, the way to write is similar. Okay, so I shall move on. Done copying, right? Okay, so moving on to this part over here. So need to know that over here, just to check with you, if this is cooling down, that means I'm likely putting it in the fridge or freezer, right? So this part here, how come the temperature don't decrease? Is it I take out from the refrigerator? Did I take out from the refrigerator for this horizontal line part here? So what's happening over here? Did I take out from the refrigerator or is it still inside the refrigerator? What do you all think? Still inside. Why? Because the temperature remain constant to do what? To undergo a change in state. Hello, can you highlight it? So temperature remains constant. That means I am still putting inside the freezer throughout. The whole time is still inside the freezer. But the heat loss is not to change the temperature. The heat loss is to change the state so that you can increase the forces of attraction between the particles. Yeah, so that means they lose heat to do different things. Sometimes lose heat to lower the temperature. Sometimes lose heat so that they don't have so much energy. And if they don't have much energy, they cannot separate. That's why they will be stuck together. That's why changing the arrangement. Yep, so that's why it's mentioned over here. Move closer and start to depend on what is it like. Like, are you becoming liquid or are you becoming solid? Then you write accordingly. Then take note, okay, that for the movement, don't just copy from the notes in front, must include the speed also. Yeah, because as things get put down, they will move slower. Highlighted. By the way, when they say refer to the table, it's referring to the first page of the table. Okay, then over here also, let's highlight the keywords also. Yeah, so not only telling me how they move, must add in the word slower. Highlighted. Okay, so yep, let's wait. I think I missed out highlighting one more point. Can you also highlight this part? Yep, so need to mention that the particles are coming closer. Highlighted. Highlight. Okay, then let's move on to the heating curve. So for the heating curve over here, so this would be also likewise. Whenever it is diagonal line, it will be two states. So take note, okay, that throughout there is heating. Oh yeah, then in that case, let's write it for the previous page also. Okay, so I'm back to the same page as just now. Take note that throughout the whole time, there's cooling happening. Hello, can you add it in for me? Throughout the whole time is cooling. So throughout the whole time, it's still inside the freezer or refrigerator. Label. Done copying? So for the next page also, throughout the whole process, there is heating. That means the Bunsen burner is not turned off. Throughout the whole duration, there's heat continuously supplied. And then let's copy quickly the same stuff again. If it's one state, it's diagonal line. Two states, it will be horizontal line. And usually horizontal line got processes happening. Let me ask you a question. Since you all learned this chapter before, so should be able to answer me quite some stuff. Okay, so if I were to have, okay, so I think you all can tell, right? All these are pure substances, right? How do you know that this is a pure substance from the graph? How do you tell that this is a pure substance from this graph? Correct. Do you realize the melting point is fixed at this particular temperature? Okay, so now, if I want you to draw the graph for impure substance, how do you draw the heating curve? How do you draw it? You don't know how to draw? Okay, so it seems like you're not sure how to draw, is it? Okay, we do section by section together, okay? I don't want to review the answer. First section, do you think is it the same or not? The slant line. Okay, or maybe first thing is, what does impurity do to the curve over here? Which thing will change? What thing in this graph will change when impurity is added? What will change? Anyone?
Maybe the melting point is different.
Very good. Yeah, the boiling melting point will be different, right? So that means this part here will still be the same, correct? So that's why I can draw a line go up first. Okay, so when I draw the line go up, how long should I draw this line? Next, do you all remember when we talk about like maybe melting point? Just like I mentioned, right? When you add impurity, what happened to the melting point? Does it become higher or lower? Lower, correct. So that means when you draw the melting point, maybe draw like that will do lah. So that it will be lower. Okay, so if it's a melting point, you draw it lower. If it's a boiling point, you should draw it higher. Because I told you, right, hot become hotter, which is the boiling point. Cold become colder. So freezing and melting point will become lower. Then next is, since it melts and boils over a range of temperature, instead of a horizontal line, it must be a range of temperature. So you, instead of horizontal, right, you draw it slant up a little bit. Can you see? From horizontal, you slant up a little bit. Yep, so this would show you that now it will boil and melt over this range of temperature. So now you see, your melting point become a range of temperature now. Let me write the melting point clearly. Yep, so that's the effect of impurities. So it will boil and melt over a range of temperature. Then the next part here, you continue on. Done. Okay, so need to know how to draw for impure substance. Should be done copying by now, right? Okay, so moving on. So next part over here, the key points are similar, just directly opposite. So I would say the ones you should study would be this box, this box, this box, and this box. Yep, so this first box over here, need to know that temperature is constant because there is a change in state. And the heat gain is not to increase the temperature. The heat gain is to overcome the forces of attraction. Next, over here for the arrangement, need to mention that they move further apart. Then you copy down whatever you learned from the table on the first page. Then over here, remember to add in the word more 50. That's why I put a star. Have you highlighted all the key points to study? The rest you all should know, because the rest you can just copy from the table in front. Done annotating, right? To check Alicia and Isabel, you're done highlighting and noting now the star things to study. Okay, then I move on. Okay, so moving on to the next part over here. This one I think quite basic. Like you all should know the difference between evaporation and boiling. I leave it to you to study on your own. Next part here, again, model answer. So if question were to ask you, in terms of particles, can you explain what's going on during evaporation? So whenever they mention that in terms of molecules or particles, this is the answer. So you need to know that during evaporation, particles, when they have enough kinetic energy, they can then overcome the forces of attraction. So only when they can break apart the attraction, they will then be separated and be able to escape the surface to form water vapor. Okay, then next is how do you know if substance is pure or not? The best method is check boiling melting point, which we keep emphasizing just now, right? That it will change if there's impurity. Okay, then yep, we are done already for this chapter. Okay, so for this chapter, let's take a look at the mock exam paper, question 7. Question 7. No, question 7. Wait, I see wrongly. Oh, sorry, open-ended. Yeah, open-ended section, question 27, sorry. Open-ended question 27. Sorry, I say wrongly. Yeah, this one. Open-ended question 27. Flip to the correct page. Okay, come, let's check your answers. So you see, ta-da! Do you realize that this is actually the answering technique? So if you read through the notes before you do the mock paper, you have to score it, right? Then isn't it the same? Why remain constant? Because it's to overcome the forces of attraction, depending on the mark allocation, right? If it's 2 marks, you must copy exactly the same from the notes in front, so that it's a more complete answer. But this one only 1 mark, so actually can shorten a little bit. And so I write down AT, means answering technique. You just refer to the notes in front will do. Yep, so must have 2 key points to get 1 mark. Moving on to part B. Substance X is used commercially for the manufacture of perfumes. Suggest a reason and explain why. Okay, so usually when they say suggest, is the kind of mark that's harder to score. So usually this kind is to distinguish between the A1 versus A2 students lah. Yep, so this one is like whether can you think of concept that you have learned previously. So actually when they say suggest is that it would be because for perfume, like just now when I spray, it must become gaseous state, right? So that it can move. Because if it's liquid like water like that, I pour out liquid, it will just drop onto the floor. So to become a gas, it must be able to change from liquid to gaseous state. And how to change from liquid to gaseous state? Best is the boiling point to be lower. Because if your boiling point may be like so low, lower than room temperature, it means the heat from room temperature is enough to boil already. Then it will have become gas, right? Yeah, so that's why based on this diagram here, can you see that the boiling point is like quite low, like 79? Yeah. Usually in chemistry, high is like above 800. Yeah, 800 degrees Celsius is high. So chemistry threshold quite high. So if it's 79 degrees Celsius, it's considered low boiling melting point. Yeah, so that's why, since it's quite low, it will be able to easily become a gas. Then will be able to diffuse easily to the surroundings. So same thing, 2 points to get 1 mark. Okay, I shall move on. Next would be part B. Using your knowledge on this topic, describe what happens to the particles in the substance as you heat up for the first 25 minutes. So you look at the graph, first 25 minutes until here, right? So it's A, B, C. The same thing, like just copy from my notes. Remember the table just now? If you copy from the notes, actually you will have scored. Okay? So let's write it down at the side. You can actually copy from notes. So if you haven't do it yet, you go home and then you copy from the notes, then you then check your answer lah. Can you just write down or copy from notes? So I shall move on then. This one, I will give you the answer key later lah. So later you just check. Okay, so moving on, nothing much to explain because it's just copying. Okay, so I'm done for the note section already. So now let's run through all the mock exam answers now. So we start off from the first page. Yep, so here's the MCQ answer. Can I squeeze everything in? No, okay, I show the first 10 first. Yep, so can you check your answer for the first 10 MCQ? Yep, check your answer for the first 10 MCQ. So if you all haven't do this paper, like maybe somehow you didn't know that need to do the mock exam paper beforehand, maybe you just sheet the answer in this OAS sheet first. Then when you do already in the question, you can come back to this OAS sheet to check if your answers are correct. Okay, I scroll down. Then the next 10. To be done by now, right? Okay, come, let's go through the MCQ answer now. I'll go through page by page. We start with this page first. Okay, so for this page, anyone need me to go through any question from this page, like question 1 or 2? Anyone need me to go through? If you need me to go through, you tell me. If not, I'll just move on to the next page. Question 1. Okay. Okay, so question number 1 over here. 2 hazard symbols and a no smoking sign is shown. And they're asking you which statement best describe why smoking is prohibited at the petrol station. Okay, so now let's check what does each symbol represent. So you can refer back to the notes. This is from the first chapter, the general science topic. Okay, so let's take a look at the notes. Let me change the screen. Okay, so the scientific endeavor, the symbols over here. So what's the first symbol that you see? You saw this, right? It is flammable. So can you copy it down? Under the fire sign, can you write in the word flammable? Hello, can you write down the word flammable under the fire symbol? Write it down in your question number 1 of the mock exam paper. Then the second symbol you saw is this, right? And then can you write down the word explosive? So for the second symbol in your mock exam paper, question 1, can you write down the word explosive? That's why they have the no smoking symbol. So written down already, right? The word flammable, first one, explosive, second one. Yep, so that's why smoking is prohibited because it's flammable and it might explode. It might catch fire. Which option do you choose? You choose A. Smoking is prohibited as it releases oxygen. Okay, so for the oxygen, you refer back to the notes. Oxygen would be, did it show here? This one. It should be oxidizing, but don't have this symbol. So if you want to react with oxygen, should have the oxidizing symbol. Because oxidizing comes from the word oxygen. Yeah. So you can write it down also that this one is for the oxidizing symbol, but they don't show the oxidizing symbol. So can. So question 2, okay, right? Moving on, next page. So for question 3, this page, anyone need me to go through? Let me go through anything from this page. So for those online, if you need me to go through, you must let me know. If not, I'll just keep moving on. Can? Okay, then we move on to the next page. This page, any questions to go through? This page. Question 5. Okay, only 5, Okay, so for question 5, an object is placed on a beam balance and a compression spring. First, do you know what does each instrument measure? What does beam balance measure? Very good. While compression balance measures the, not volume, weight. Yeah, weight. So need to know what each instrument measure. So in this case, for the mass, you all know, right? Even when you go to like other planet, it will remain the same. But the weight will change according to the gravity, right? Yeah, so if the gravity pull is stronger, then obviously the weight is greater. That's why it should be same, and then the other one is different. So you choose that's all. Done. Okay, so moving on to the next page. Question number 7, this page. Which question you want me to go through? Only question 7. Need me to go through question 7? Option 3, sure. Okay, so they said that if a saturated solution of KClO3 were to be cooled from 70 to 30, 10 grams of solid would be formed. Okay, so let's take a look. KCl is this line. From 70, which is here, is about 50 grams like that, okay? You cool it to 30. 30 is over here. It's kind of in the middle. I would say kind of around like 35 gram like that. Yep, so from 50 to 35 gram, this is a difference of 15 gram. And they said that 10 gram of solid would be formed. So it's not true law because it should be 15 gram formed instead. So why you minus means the solid is formed? Because they are trying to say that when it's hot, you all know, right? When things are hotter, can dissolve better, ma. So that means I can dissolve 50. But now at colder temperature, I can only dissolve 35. So the difference, that means just now I can dissolve 50, but now I can only dissolve 35 means some of them cannot dissolve anymore. And when things cannot dissolve, isn't cannot dissolve means that they are in solid state. So yeah, that's why got solid form, right? Because like example, sand cannot dissolve, isn't it solid? Yeah, so that's how you get the answer. Anyone need me to explain option 1 or 2? Need me to go through 1 or 2? Don't need? Okay, then we move on. If need to go through, must let me know. If not, I'll just keep skipping. Okay, moving on to this page, question 8, this page. Need to go through any of the question? Okay, I think I went through just now, right? Okay, then we can skip. This one, this page we also went through just now. Okay, skip. Question 12, this page we also went through, right? Then we skip. Then you go to this page. Question 14, this page. Need to go through any of it? 15. Okay. Any more questions to go through? Only 15, huh? Which statement about division of labor are correct? Okay, so what exactly is division of labor? Let's refer back to the notes. Sorry, let me click open the notes. Yep, so let's go to cells. Okay, so for division of labor, where is it? Over here. Can you flip to your notes, page 24? Hello, flip to your notes in front, page 24. What is division of labor? Division of labor, I will say that it is called like multitasking. So that means like, for your heart cells is meant to like pump. Then maybe your cells in your digestive system is meant to digest food, right? So you see, different cells do different things. So that's called division of labor. Hey, you this cell, you go and pump blood. Hey, you that cell, right? You go and digest food. Then another cell maybe do something else. So that's called division of labor. I divide the labor. I divide the workload out. Yep, the act of dividing the work among the different cells. So for division of labor, this is to make it that you are multitasking. Multitasking means you'll be more efficient because at the same time, you can perform many functions. You can perform specific function effectively because maybe that cell is mainly specializing in digesting food. They are very good in digesting food, ma. That's called specializing one. Like for example, if I say that I specialize in science, it means I can teach science very well, but I cannot teach math lah. I cannot teach English, something like that. So that means you're good in that particular area. So that's called division of labor. You divide them to do the function that they are specialized in. So that many functions can be performed at the same time. So need to know that only if you undergo cell specialization. What is cell specialization? Cell specialization means that you actually specialize in performing a specific function well. So maybe like I specialize in science, right? That means I teach science. So maybe if it's a root hair cell, what they specialize? They specialize in absorbing water and mineral salts. Yep, so that's called specialization. So you can relate to us human, easier to understand also. Yeah, so only if you are very good in performing that specific function, you then can do this multitasking, because each person do their own job very well. So based on this information over here, let's go back to the mock exam paper. Yep, so they said that division of labor only exists in animals. This one is true. Sorry, not true. Because in plants also what? Like for example, plants, you have different things, right? Like you have root hair cell. What do they do? Root hair cell absorb water. Then in plants, you also have some other cells, right? Like maybe stomata. Stomata, it would be to exchange of gases. So you see, they are still dividing the load. Everybody do different things. Then you also have like the phloem or the food carrying tube. Then it transports food. So you see, everybody is doing different things. Yeah, so it's not only in animals, it's in plants also. Okay. Next, the different types of cells have different functions. It's true that I already mentioned over here. So that's why number 2 is true. Number 3, it allows organisms to carry out more complex tasks. True, because you can very specialize in doing this complicated task very well. So number 3 is correct. And number 4, division of labor. Wait, how come these two options are the same? Then like that, isn't it like everything is correct? Oh, then like that is everything correct. Because not only in these two sentences is the same, right? And my eyes not same only, right? Then it should be D, right? Yeah, I think it's a typo error. By right, should be 1 and 4 should be different option. I think like got some typo error. Okay, can you change your answer to D instead? Yes, correctly. It's correct, right? The first sentence and fourth sentence is the same.
Isn't the answer B?
Oh yeah, sorry. Thanks for saying yeah, correct, right. Sorry, blur me. Only the second and third one is correct, so should be B. Sorry. Yeah, so can you change it to B? Yeah, change to B, yeah. The answer is B now. Okay, let's move on to the next page. Question 16, this page I went through already, right? Then moving on to the next page. This page I haven't go through the below. This one, anyone need me to explain? Okay, I'll go through. So for this question, they're asking you, which two of them have similar chemical properties? Okay, so you need to know that to be same chemical properties, they need to be in the same group first. Why? Because if you are in the same group, this is an atomic structure topic. Same group, you know that group number tells you the number of valence electrons, right? You know that? By the way, just a quick recap. What does group number tell you? Group number tells you the number of valence electrons, right? What about period number? What does period number tell you? You know group is this way, right? In the periodic table. And then what's period number? So if period 2 means it has 2 what thing? 2? So do you all know what does period number tell you? So you all see the periodic table or the period number, you all don't know what it means, is it? What does period number means? The horizontal line. Like period 2 means got 2 what thing? No one knows.
Electron shell.
Thank you very much. Yeah, period number refers to the electron shells. Can you write clearer? So that means if it's period 2, you have 2 electron shells. Period 3 means 3 electron shells, okay? Yep, so in this case, if you have the same group, you have the same number of valence electron. So that means, example, if you are in group 17, you have 7 electrons. That means you need 1 more to get a full shell, right? So that's why everyone in group 17 definitely want to gain 1 more electron. So if they gain the same number of electron, means they participate in chemical reaction the same way. And chemical reaction refers to chemical properties. Okay? Yep, copy it down. Yeah, so can you copy the explanation here also? Copy in. Just write everything in. Just to let you all know, all these kind of explanation is not in the answer key, okay? My MCQ answer key only got A, B, C, D. Yep, so copy all the explanation down. Have you learned the topic of atomic structure? Or maybe your school postpone it to next year, then this question not applicable for you. Yeah. Once everyone done copying, then I'll move on. Okay, so seems like you are done. Just confirm, Isaac, you done, right? Are you done or not yet? Done, really, I clear the screen and move on, Okay, so moving on. Okay, so for this page over here, question 20 on atomic structure, anyone need me to go through? Okay, if your school never include atomic structure for Sec 1, means that they will postpone it to Sec 2. Yeah. So don't need, all good? Okay, then we move on. Okay, come, let's take a look at your question 21. So they are asking you, suggest one variable that should be kept constant and one variable that is the dependent variable. I think you all know that dependent variable is actually the result of the experiment, right? Yep. So what's the result that you're recording? You're recording about how much weight you can hang.
Wait, after the how much weight you can hang, I wrote before the break.
Can. Actually, your answer better, more clearer. But anyways, they just say variable. So actually, just state the variable will be like. Yeah, your behind is like more like description, explanation. Okay, so I shall move on. No questions, right? All good. Anyways, if you're not done with probably correction, as mentioned, no worries. I will give you the answer key at the end of the lesson, okay? So if you can't write finish, you can refer to the answer key and slowly copy your correction at home. Okay, so I shall move on to the next question. This question here. So they are asking you which one is a pure compound and a mixture of element and compound. Okay, so how to answer this question? First, you need to know the difference between element versus compound. What is the difference? Let me now show it to you from the notes to explain to you first. Okay, let's go to the notes first. Here. Wait. Sorry, let me find the notes. Okay, so let's go to the page on chemical properties. Yep, yeah. Can you flip your notes now to page 10? So on page 10, you need to know that elements and compounds, they are considered to be pure. Why? Okay, ask you a famous example of compound. What's the most famous example of a compound? Start with W. Water, right? Water isn't it a compound? Because water is H2O. So water is pure, right? We have something called pure water, correct? So if you have something called pure water, then this compound can be pure. Then mixture is, they already say they mix things up. So obviously you mix things up, it would be impure. Now, how do you differentiate? When is it considered element, compound, or mixture? So it's actually mentioned over here. So you go by this. Element, it is, okay, or maybe I don't use the words, I write over here. Okay, so how you go by, how to remember is, you go by this. Element is only one type. That means if you see the whole, like maybe they draw a ball, then draw a lot of particles inside, right? If all of them are all maybe oxygen, and then that's element, that means there's only one type. Compound, it would be two or more types. Oh, just now remember you mentioned about water. Water, isn't it H and O? Got two types, correct? Got H and O. Two types. Then mixture would be depending on, maybe I mix salt and water or like sand and water. That's mixture. Okay, then next is another way to compare will be compound will only be one group, while mixture would be two or more groups. So let me draw it out for you. So for example, right, if I were to say that element is usually like this. So I'll draw it like that. See, both of them, wait, how come cannot draw? Okay. So you see, both of them are all white color circles. So this is called one type. All of them are all the same type. They are all white color circles. Compound will be like this. So maybe I have white, black, white. This is called compound. Because compound is different type. Got white and black. But how many groups are there? You see, this one is white, black, white. This one also white, black, white. You only have white, black, white. You only have one kind of group, which is white, black, white. As compared to mixture, how I draw it would be maybe like that. The white, black, white, as well as maybe like that. So in this case, we would say that this particular set here is called element. But this particular set over here is called compound. So take note, whenever you study this topic, right, you have to look at them by per group basis when you look at the diagram. So this is the technique. In this group, same type, you use the word element. In this group, different type, you use compound. Okay? So same type versus different type. Maybe I write it in clearer for you. So this would be same type. This is different types. You see the circles? Yeah, so always look at them by per group basis. Same type, different type, same type, different type to decide element or compound. Then next is you see how many groups are there. Can you see that there are two groups? Got the double white group and white, black, white group. So two groups, you use the word mixture. Okay, so that's how you differentiate them. So now if we were to go back to the question, you're done copying, right? On page, what page is this? I can't really see. You're done copying, right? I move back to the question, okay? So back to this question, when they ask for pure compound, I already told you, compound and element confirm is pure one, okay? So the word pure over here is just to trick you. Just choose compound. What did I say about compound? Compound, just choose different type. So you see, for C, same thing, you always look at per group basis. So in this group, is different type. There you see? So this one isn't it one group only. You only have the 4 white, 2 black group. Correct? Everybody is the same. Only got one kind of group. Plus, they are different type. So, yeah, this is a compound because compound must be different type. Okay, then next one is mixture of element and compound. Isn't it like that? Element and compound mixture. So that means you must have two different groups. So it will be E because you see, this is element cause same type. Then this is different type. This is compound. Hello, can you follow and label it in? Copy it down. Yeah, so this element, this compound. And then this one has two groups. Yeah, so two groups would be mixture. That's how you get the answer. Let me go through the rest. Come, let's answer it. Okay, so for the first one over here. Okay, so maybe we take turn and then I go around to ask questions. Okay, so maybe I start off with Elliot first. I go this way, yeah. So I start from Elliot first. Okay, so Elliot, let's take a look at group by group basis. We look at this group over here. What word can you use to describe? Element or compound? Correct, because only one type, right? Element. Good. Okay, then next, Sean, if I look at just this group alone, what word can I use to describe? Element or compound? Correct, because only one type. Then I move on to N. So in this case, the whole box, what can I describe it as? You know what word to use? We only got element compound mixture, right? So any other word to describe or that's all? Yes, mixture, because there are two groups. So as long as you have two groups, this would be mixture. So A is actually a mixture because you have two groups. There you see, two groups. So that means this box is called mixture of elements. Okay, right now on the side. So A is called mixture of elements. Okay, then let's continue on to B. Then I just continue on to Yushen. So Yushen, let's take a look at each group one by one. So this group, what word can you use to describe? Correct, because only one type. And then no more other group, right? So then for Zihan, any other words can I use to describe for this box? Or is that all? Correct, that's all. So B is just element. That's all, nothing else to add on. Then we move on to this one. This one I went through just now already, right? Okay, so maybe can I get wait, after Zihan is Jia Yi, right? So Jia Yi, this box, what can I describe it as for this box? Correct. Any other words to describe? Is that all? Yes, that's all. Because only got one group. So it's not mixture. Good. So it's just compound. Okay, then I move on to, sorry, beside Jia Yi, I didn't catch your name. What's your name? Kaylin. So Kaylin, we now move on to box D, okay? So for this part over here, what word can you use to describe? Correct, because only one type is elements. Okay, then I move down to Isaac then. So Isaac, this box, any other words to describe? Or is that all only, is it only element or what? For box D. Yes, that's all correct. So it's just element. Hello, everyone. Are you copying down the description for each of the boxes? Can you write it down? Okay, then moving on to Isabel. So Isabel, for E, since I went through already, what can I describe E as? What can I write for E? Can you say a mixture? Correct. Any other words? Is that the only word or that's all? Or what? Isn't E over here? I went through just now, right? So E is just this one more mixture of, so it's not that's all. So mixture only says two group, but you need to look at each group. Okay? So Isabel, you see this group, same type, so must have the word element. This group over here, you see Isabel, different type, and then have the word compound. Okay? So must include the types. Yeah, so mixture of elements and compound. You need to tell me what you are mixing, like maybe I mix chocolate and vanilla ice cream, something like that. So you cannot just say, oh, I mix, but must tell me mix what thing. Okay, then moving on to F over here for Alicia. This group, how would you describe? Compound, correct. Then the rest all, oh, no, there's one more. So Alicia's friend, sorry, I didn't catch your name because you came late. What do you think is the answer for this over here? Correct, because different type. Hello, are the rest of you copying? Can you follow and copy it down? Sorry, my teaching style is like that one. I very kiasu, very naggy, so I always write a lot of things on the screen. Yeah, so my student always a lot of things to copy down, which is good because you come for tuition is for the explanation If you don't need explanation, you just buy assessment book from Popular, then just do on your own, right? Got the answer key there. Yeah, so usually for tuition, I do a lot of explanation. That's why you realize, wow, I write a lot of things inside. Yeah, which is good because when you come to end of year exam, then when you revise, even things that I mentioned in January, at least you have it all annotated. Yeah, so that's my teaching style. Okay, so then now you have two groups over here, right? So now I move on to Maxim. So what other words can you use to describe for box F? Besides compound, what other words can I use to describe box F? Any other words that I can use? Very good, mixture, because there are two groups. You see, got the white black group. Hey, wait, why am I circling? Why circle the same one? Sorry, blur me. I should circle a different group. Sorry. You want to circle like that, like this two circles versus three circles. Yep, so two groups, that's why it's called mixture. So that's why for F, it is called mixture of compounds. Done copying for N? Have you copied? Yes, so it's a question.
Right. Isn't there like two types of elements?
Yeah, correct. So you can also write as mixture of elements, like to say two types of elements.
Okay.
Yeah. Okay, done. Let's move on. Okay, then the next part here. When making cakes, we often beat eggs with granulated sugar instead of coarse sugar. So they ask you to explain why. So this one is because he has a larger, because talk about the particle size. Yeah, so smaller particle size means that they can dissolve faster. Do you have the word smaller particle size? If have, then yeah, you can get the mark. Moving on to part C, what's the difference between mixture and compound? So there are many possible answers. You just need to state one will do. So you can tell me about the property being different from its constituent element. By the way, what does it mean by constituent element? Constituent means what makes it up. Yeah, the element is like the original. Remember, element is one type. So that means what types makes it up law. Yeah, so that means like okay, so example, the constituent elements of water is hydrogen and oxygen. You understand? The constituent element of water is hydrogen and oxygen because it's made up of the type is hydrogen and oxygen. As compared to mixture, mixture will not have different properties. It will be same property instead. Next, the element, you can talk about the proportion by mass. So for example, our favorite example of compound, isn't it water? And for water, do you realize the proportion is always the same? Water, based on the formula, is H2O, right? That means it's always in a ratio of 2:1. Yep, so that's why the ratio is fixed, 2:1. Or you can mention about how are they combined or broken down. So you can mention that, for compound is cannot be broken down by physical methods because compound is broken down by chemical method. Yeah, so you can tell me that it's broken down or combined by chemical means. I will also accept. Oh, lost this. Yep, so these are all the possible answers. Any of you have any other answers you want me to check for you? Yes, Sophie?
Maybe like, can I write a compound is made out of one group of two or more types of elements, while a mixture is made out of two or more groups of compounds or elements?
That one is more like, let me think, made up of. Okay, that is true, but usually if you were to do enough practices, we tend not to write about that point, because that one is more of like the understanding, like, I teach you concept just now, right? Like, is it made out of same or like different? But when we write as the answer, usually we will tend to write its properties instead. Yeah, so like the properties same or different, then the proportion and stuff. Yeah, so I will recommend that you don't write that as the answer. If the teacher lenient, maybe can, but for me, when I mark, I will not accept it, even though it is true, because when they ask, you should write about its property. Yeah. Yes. She said that she want to write as mixture is like got two or more substances, while compound is like two or more like elements. Yeah. Then that is under point number 3 also can. Yeah, correct. Because you got the point number 3. Yes. Physical properties change when compound is formed. That would be point number 1, can. Then you write for the other one, like mixture, how is it? And then you need to write both, you cannot only write compound. You need to answer both. So like that incomplete. Yeah, so you need to do correction then. Any of you have any other answer? All good? Okay, then we move on. Done with correction, right? But no worries lah. Even you're not done copying, I will give you the answer key later. Moving on. This one I went through just now. Skip. This one I went through also. Skip. I went through also. Right? Yep, then skip. Okay, 26. Come, let's check your answer. Describe one change that had taken place in the cell. So you just compare, what do you notice? So you realize that, everything, like this line, right? Can you see this line here? Became like that. Yeah, so that means the cell membrane shrunk. Can you see this is the cell membrane? So take note that like that is like that. This, can you see this is a layer? This layer is cell wall. So cell wall is like a layer. While cell membrane is different. Cell membrane is a line. Cell membrane is a line. So take note. So cell wall we usually draw with 2 lines. Cell membrane we draw with only 1 line. Another possible answer would be, you can tell that the cell membrane no longer touching the cell wall. So once the cell membrane no longer touching the cell wall, if there's IP students here, your teacher might have taught you this word plasmolyze. So plasmolyze just means cell membrane don't touch cell wall. Or if you know even more in detail, the third one a bit hard to get the answer, is that the outside solution would actually fill the space over here. Wait, maybe color code it. Maybe I color code it in yellow. This one here would be here. Maybe this region here. Can you see this space? This would be the space where, like, if you soak it in sugar solution, it will be filled with sugar solution. So now I have a question. One, do you think this space here is filled with the sugar solution? Anyone have any idea why this space is filled with sugar solution? I give you one hint. A property about cell wall. What about cell wall? Why sugar solution can come in? Why? What's the property of cell wall that allows sugar to come in? Hello, anyone? What's the property of cell wall such that the sugar solution can enter and stay in this space over here? Yes, correct. Thank you. Yeah, because cell wall is fully permeable. That means every substance can pass through. Okay, so P for permeable, P for pass through. So it's fully allow all particles to pass through, big or small, all can pass through. That's why here is filled with sugar solution. Need to know, this space here is not vacuum, it's actually filled with the solution that you are soaked in. Have you all labeled this? Yes, Jaden, you have a question?
Yes. So right, last time when I was doing a mock exam in my school, right, the marker said that cause right, I had similar question like this. It was about drawing a plant cell, right? But when I
Then
was drawing a cell, there's some broken lines. Cause when I try to complete the circle, right, they would like there's a little line that overshoots at the end.
wait, sorry. Can you lower your volume a little bit? Because I cannot quite hear Jaden. Okay, about the line part, can you repeat? I couldn't hear that part already.
So right, when I try to draw the line,
Uh-huh.
right, like
The orange line?
kind of like sketchy and broken. Like cause I was drawing halfway, then I
Uh-huh.
let go of my hand and put it again to continue drawing. And so it turned out kind of like this. And then like that it is over here is like like it's separated.
Oh, like there's a hole, is it?
No, not really a hole. Like it overshoots like a line coming out a bit.
Uh-huh, then.
So right, so then the examiner penalized me saying that cannot have sketchy and broken lines. But is it even
Yeah.
the lightest one cannot? Cause every time I draw a circle, there's always a little nut at the end.
Okay, because biology, they have this requirement where you need to draw smooth, continuous line. That's why you cannot have like
But while I was trying to
extra
complete the
lines
circle,
and
there will
all.
be a little nut at the end. Is that okay? Like there's a little line
Cannot,
between.
you have to really draw. Like you just now, the particulate nature of matter I was saying, the particles, you cannot draw like that overshot also.
So
Yeah,
yes,
you must really draw it perfectly.
if I draw it wrongly, I have to erase and draw the entire thing, not just the part that I got wrong.
Yeah,
Not
so you learn from mistake then, yeah. So science usually the drawing they are quite strict, yeah. So you really need to follow the criteria for drawing. Okay, come moving on to the next part here. This one I went through just now, right? Correct, okay, then we move on to question 28. Come, here's the answer. So this is atomic structure lah. So if your school don't cover atomic structure, then this part you can skip it lor. Yep. So anyone need me to go through A, B, or C? Anyone need me to go through A, B, or C? By the way, just to let you know, this is actually an answering technique. It's a standard model answer. Okay, you go and like memorize it. Yeah, because once you have all the keywords in, then yeah, that's the full marks already. So you all can understand, right? Need me to explain? All good. Okay, so wait, before I review the answer key, right? Yeah, wondering like it is possible for you all to like give a short feedback so that we can know how to improve our subsequent lesson. Because today is like just the first lesson, right? So you provide us the feedback, then we can know like how to make the lessons better. So can I like get some all of you to like set a little bit time to like scan the QR code now to fill in this survey form. Yep, then if you fill it in now for the physical attendees, I'll give you a overmark full set pen. Yeah. Yeah, so please help to fill in the form. For those online, can you also help to fill in the form, please? Thank you. Yeah, so you see, we spend the time to like, conduct the lesson, prepare the materials, yeah, teach you all the lesson today. Like, you spend so much time. I just only need to spend 1 minute of your time. Yeah, so can you help me to like fill in the form, please? Thank you. Don't need. Any email address. You hold on, I go and get the set. Thanks everyone. Hope today you all managed to learn like some skills that you all didn't pick up in school and hopefully like clearer in terms of the concepts. Yeah, so if you all like such revision lesson, just to let you all know, Overmark actually has such revision lesson every September. Yeah, so even next year, you all can still join again for the free lessons. Yeah, so just need to follow Overmark on Telegram and Instagram, then we will always announce it. Thank you for filling in. Once you are done filling in, you just show me from your phone, then I'll just give you the skip pad. Oh, okay. Let's see. Thank you.
Miss, how are you gonna give us like, are you gonna give us like a QR code for the answers?
Yes, I'm going to give the QR code after everyone done with filling in the survey form. I'll give it later. Soon. Yeah. Thank you. Okay, thank you. Anyone else done? Then I can maybe give you the full set pad. It's very cute, you see. And this good quality paper, okay? You touch the paper, it's like thick one. It's not the cheaper one, okay? Yeah. It's good full set pad. Okay, thank you. Oh, I have finished it first. People, hold on, I'm going to give the answer key soon. Wait. Anyways, meanwhile, waiting for you all to fill in the feedback form. Okay, thank you. Okay, so anyways, meanwhile, waiting for you all to fill in the feedback form. Just to share with you all that like if you thank you. Yeah, so if you feel that like you need more help in science, like you realize, oh no, like today how come a lot of things that like I mentioned, then like you are not aware of it. Yeah, so if you need more help, we are here to help. Yeah, so if you want, if you're interested to join, we actually have booster classes here lah to help you with the last lab law right before the end of your exam. So it's just like 4 weeks. Then this is like the pricing. Yeah. So if any of you might be interested, you can scan this QR code. Then the Overmark admin, then they will contact you like, to reach out to you. Thank you for having to fill in. Any more of you fill in the survey form? Then I give you the full set pad. Thank you for filling in. Thank you for filling in. Thank you for filling in. Okay, then done filling in. Okay, thank you for filling in. Okay, then yep, so here's the answer key that I promised. So y'all can scan the QR code and remember to save the document okay? So that you can have a copy of the answer key. Yeah, so this is the answer key for today. Just with that, that's all for the lesson for today. So thanks for your time. Yep. So just to remind you all, okay, that for the next lesson, if you are attending the Set 1 math lesson, same thing, remember to finish the mock exam paper before you come for class. And if any of you here didn't collect from the MRT station, you can collect the math paper from me. I have some excess copies here. Okay? Yep, so that's all for today. You can take and read already there. Bye-bye.